Yes, I welcome you all. Today we have a paper from the Giant Examination Board, and it is a mathematics paper that was done in 2024, and it was a mock paper. The time allowed was 3 hours, which is the normal time for South Sudan national examinations. So we shall go through this paper step by step, and we shall attempt every question that was said. So briefly, we know every paper has instructions and which you need to follow accordingly. I'm going to talk briefly on two main items because they're important in the instructions. That is, the paper consists of two sections, section A and section B. And section A is always compulsory. That's why they've said attempt all the questions in section A, and section A carries 40 marks. So in section A there are 10 numbers, each number has 4 marks, and they're saying attempt only 5 questions in section B. Section B has 7 questions and we attempt only 5. Each of the questions in section B has 12 marks. Therefore, a total of 60 marks from 5 times 12. But for the purposes of this class and for the purposes of revision, we shall attempt all the questions that are in section B. Section A is compulsory and therefore it is mandatory for us to do. In the national exam, you are required to answer in the spaces provided. But for this class, I will be using a separate answer sheet because I will be solving the same question using all the possible methods. All the possible methods or ways of solving a given number, I will be in position to do them. That's why I will be using a separate answer sheet. So let us go to section A. So going to section A of the Giant Mock Examination Board Mathematics Mock of 2024, and as a reminder, we are Vision Plus. So section A, number 1 says that we need to solve 1 over 2 into 3x minus 2 close is less than 1 out of 3 into x plus 4. That is the given inequality. This one is inequality simply because we have an inequality symbol here, which is less than. So we solve this and we represent the solution on a number line. There are two approaches that I'm going to use. Approach 1, which I will call method 1, is operation of brackets. I'm going to operate those brackets. Which in actual sense, they are called parentheses. Anyway, this is very important in basic math. In additional mathematics. In basic, we can call them brackets. But in additional, they are not brackets. They are parentheses, which is actually what they are. And in method 2, I will use method of LCM. I will get the LCM and we shall talk more on that. So starting with method 1, and let me copy the question. The question is, we are given 1 over 2 into 3x minus 2 is less than 1 out of 3 into x plus 4. In the method of operation of brackets, we simply multiply all the terms in the bracket by the coefficient of the bracket. In other words, we multiply each of the terms inside the bracket by the term which is outside the bracket. In this case, it is a half. I assume you know these symbols, but this symbol means less than. And you remember from your laws of inequalities, an inequality symbol can be read in two directions. So I will not go deep into that, but in case you are not familiar with it, go and watch our list of videos on that. So I'm going to operate by opening the bracket. What is a half times 3x? A half times 3x is 3x over 2, then minus. What is a half times 2? A half times 2 is 1, because we shall divide. 2 divided by 2 is 1. 1 times 1 gives us 1. So a half times 2 is 1. I have operated the bracket of the left hand side. And then you keep the inequality symbol the way it is, less than. And again we operate on the right hand side. 1 out of 3 times x, it gives us 1 out of 3x. And then 1 out of 3 times 4, it gives us 4 out of 3. I have operated the brackets. What is left now? I'm left with collecting the like terms and simplifying. So I'm going to carry this 1 over 3x to the other side. Therefore, I will have 3x out of 2. If I carry this one to this side, it becomes a negative. So we'll have minus 1 out of 3x is less than, you keep the symbol, and then we take this negative 1 to the other side of the equation. It becomes positive. So here we shall have our 4 out of 3, which was here. This 1 becomes positive, so plus 1. Remember, we treat the inequality symbol like an equal sign, but we never change it to equal sign. It has the same properties as as the equal sign, but it has other extra properties that the equal sign does not possess. Then here now we simplify. What is 3 out of 2 minus 1 out of 3? We simplify this. You can press the calculator. So 3 out of 2 minus 1 out of 3. Let me show that. If I factor out x, I will have 3 out of 2 minus 1 out of 3. Then I'll factor out x. Then it becomes less than. And then I add, what is 4 out of 3 plus 1? So on this side, on adding 4 out of 3 plus 1, I'm getting 7 out of 3. And then on subtracting 3 divided by 2 minus 1 divided by 3, I'm getting 7 out of 6. So here on this side, we shall have 7 out of 6x is less than 7 out of 3. But remember, we are looking for x. So from here, we just make x the subject of the formula, which you can do. So from here, I see clearly that 7 and 7 are cancelling out. 7 and 7 are cancelling out because they are numerators on opposite sides of the inequality. So 7 and 7 will cancel out, and then we shall be left with 1 out of 6x being less than 1 out of 3. And now to get x, I multiply both sides by 6. Multiply both sides by 6. So if I multiply both sides by 6, I will have 6 times 1 out of 6x is less than 1 out of 3, also times 6. This 6 and that 6 will cancel. So I will have 1 times x. I will have here x being less than 1 over 3 times 6 is 2. So in this case, our x is less than 2. This is the solution to the inequality. And if we remember clearly, they said represent the solution on a number line. So after getting our x as less than 2, the solution on a number line will be, you come and draw your number line, which is just a straight line. Use a ruler, and it has arrows on both sides, simply because this side goes to negative infinity and this side goes to positive infinity. And then you locate your middle line, your middle point somewhere here at 0. So in the middle here we have 0. You don't need to bother marking this with very many numbers. Just look at what you want to locate on the number line. It is 2. So it is positive 2. So you just mark somewhere here that you have positive 2 here, and then you mark a corresponding negative 2 here. And then you interpret. We have said x is less than 2. So first of all, where is 2? 2 is positive. So it is here. This is 2. So we are here. And less than 2. So we shall start from 2 and below. But remember, x is less than 2. X is not equal to 2. So we shall use an open circle. The reason we are putting an open circle or an open point is because x is a number less than 2. But x can be very, very close to 2. Example, x can be 1.99999 up to infinity. So we say x picks up at 2, but 2 is not inclusive, and then less than. So this side is less. This side is less than 2. So this is our inequality for x is less than 2. This is our number line, rather. Represent the solution with number line. I have used a lot of space, but in the exam, I'll only quote the necessary steps. But I've tried my best to explain every step. So this is the solution to number 1 when we are using method 1. In the next video, we shall solve the same number using method 2, and we shall be in position to get the same answer. So choose what you are comfortable with and always adhere to it. Otherwise, thank you. Vision Plus. Welcome to Vision Plus. We are looking at a mock examination paper from the Giant Mock Examination Board of 2024. We are on number 1. Now we want to use method 2. Method 2 is the method of LCM, and we did method 1 in the previous video. So in method 2, we need to get the LCM. Which LCM? We get the LCM of the denominators. And if you look here, the denominators are 2 and 3 on the opposite side of the inequality. So what is the LCM of 2 and 3? That is senior 1 work. The LCM of 2 and 3 is 6. Basically, LCM means the lowest common multiple. In other words, it is the smallest number that can be divided to 2 and 3, which is 6. After getting the LCM, then we multiply both sides by LCM. We multiply both sides of the inequality by the LCM, which is 6. So I'm going to copy the question while multiplying both sides by 6. So on the left hand side, I will say 6 times a half into 3x minus 2 is less than, and then again times 6. 6 times 1 out of 3 into x plus 4. I have multiplied both sides of the inequality by the LCM, which is 6. Then I simplify. If I divide 6 by 2, if you divide by 2 1, by 2 3. So here I will have 3 into, I don't like crossing out, we shall have 3 into 3x minus 2 is less than 6 divided by 3 is 2. So here we shall have 2 into x plus 4. And then we open the brackets, we operate the brackets. On operating the brackets, here we shall have 9x minus 6 is less than 2x plus 8 if you open the brackets. And then you collect the like terms. So I will carry this to that side. Remember, we treat inequality like an equal sign, but we never change it to equal sign. So here I will have 9x minus 2x is less than 8. If I carry this negative 6 to the other side of the inequality, it gives us positive. It becomes plus 6. 9 minus 2, 7. So we shall have 7x being less than 8 plus 6, 14. Then I say both sides by 7, both sides by 7. So if I divide both sides by 7, I will have 7x less than 14, both sides by 7. So my x here will be less than 2. This is the solution to the inequality that we were asked to find. Find the solution or solve the inequality. So this is the solution to the inequality. And the second part of the question said, and represent it on a number line. represent the solution on a number line. So basically, on the number line, a number line is just a straight horizontal line. It has arrows on both sides. This is to negative infinity, and this goes to positive infinity. In the middle here, you can mark 0 or any convenient point that you like to put there. Then you mark. You don't need to mark a lot of points. You can just mark what you have. Like there it is 2. So someone marks 2 here and a corresponding negative 2. Remember, when we are plotting inequality on a number line, if you have a symbol, if it is less than, or you have a symbol of more than, this one you use a circle, open point, or a circle. But if you have a symbol less than or equal to, or a symbol more than or equal to, then we use a solid point, simply because that number is inclusive. We have a detailed explanation on this, starting from Senior 3 Mathematics, and even under linear inequality and programming. Inequality and linear programming, you will have the same concept there. Please visit our videos. So from here, we have our variable x is less than or equal to, our variable x is less than 2. It is simply less than 2. So that is positive 2, so you come to 2. But remember, if it is just less than, then we use an open point on 2. So here we shall have open circle on 2. That means 2 is not inclusive, but there is a number very close to 2, like 1.9999. It is close to 2, but it's not 2, so we use an open point. And then if you look at the inequality, x is less, so our variable takes on values which are less, so you go down to a lesser side. So this is the representation for the solution x is less than 2. On this axis, these are just the values of x. So somewhere you can just mark x. These are the values of x that we are representing on this number line. So this is the solution to number 1. We shall be going to number 2, and in case you have questions or queries, then please leave them in the comment section and we shall look into them. In case you have another alternative that we have not done, you can show it in the comment section so that your colleagues can be in position to review it. Thank you. And now going to number 2, a reminder, if these materials and resources are really important to you, we encourage you to share with your friends and classmates. We are Vision Plus. Number 2 says, given that tan theta equals to 15 out of 8, without using tables or calculator, find the value of 4 cos theta minus sin theta. That symbol is called theta. The symbol is theta. Theta depends, but that is the symbol. So this is a question from trigonometry, and the best way we can solve this is, we have been told not to use tables or calculators. Therefore, we cannot get the angle theta by pressing the calculator and getting the tan inverse of this given number. So what we shall do here is, remember, this one is a remember sine, cosine and tan are strictly for right angle triangles. They apply strictly to right angled triangles. triangles. And there are other rules, but like the sine rule and the cosine rule, but basically these three ratios apply to a right angle triangle. So to solve this, we need to sketch a right angle triangle and then we indicate the given parameters. A right angle triangle can be in any format as long as it has a right angle in it. So for this case, I'm using my free hand, but if you're sketching, please use a ruler. So I'm going to draw my vertical line here, and then this and that. All we need to see is that there is a right angle here. A right angle is an angle of 90 degrees. So this is a right angle triangle. And now for us to assign the parameters, we say, remember, tan of any angle theta is given by opposite over adjacent. And the key way for that is we have what we call SOHCAHTOA. SOHCAHTOA. If you are looking for sine, it is opposite over hypotenuse. If you are looking for cosine, it is adjacent over hypotenuse. If you are looking for tan, it is opposite over adjacent. Now that takes us back to our question. In our question, I'm taking time here because it is very important. In our question, we have tan theta equals to 15 out of 8. So if this is our angle theta, you can put it anywhere. You can put it here or here. So if this is our angle theta, then if you look at tan, we say tan is equal to opposite over adjacent. This means that 15 corresponds to the opposite. Opposite to what? Opposite to the angle. So this is the length. This is the length which is opposite to the angle theta. So our opposite is this side. This length is the opposite, which in this case we have it as 15. And then the longest side in the right angle triangle is always the hypotenuse. So this is our hypotenuse. And then adjacent to the angle. Adjacent to the angle is the adjacent. So this length is the adjacent. And adjacent in this case is 8 units. They have not specified the parameters, but these are ratios of the same quantities. So 15 is the opposite, adjacent is 8. So we have interpreted the tan theta that we were given here. So in our right angle triangle now, we have identified the opposite as 15 and adjacent as 8. Now for us to solve the given question, here we have 4 cos theta minus sine theta. It means we first need to know what is cos theta. We have said cos theta is, you come to SOHCAHTOA, cos theta is adjacent out of hypotenuse. It is adjacent out of hypotenuse. What is hypotenuse? Hypotenuse is the longest side. So we need to get that. And also our sine theta is, sine is opposite out of hypotenuse. So we must find the hypotenuse so that we can get the cosine of theta and the sine of theta. How do we get the hypotenuse? Remember, this is a right angle triangle, and Pythagoras theorem applies to right angle triangle. So by Pythagoras theorem, Pythagoras has many names anyway, but it's the same person. Pythagoras theorem. Some books call it Pythagoras, others say Pythagorean. It is all the same. Now, it says that the sum of the squares of two shorter sides equals to the square of the longer side. That means if you get the opposite, we square it, plus the adjacent, we square it. It must be equal to the hypotenuse squared. So if we square the two shorter sides separately, then we sum them, it gives us the square of the longer side, which is the hypotenuse. Therefore, we shall have 15 squared plus 8 squared equals to hypotenuse squared. Then you square sum them. So here I'm getting 289 equals to hypotenuse squared. But we are looking for hypotenuse, so we take a square root on both sides. Therefore, our hypotenuse, we take the square root on both sides. I'm getting 17. So our hypotenuse is 17 units. So this length that we had not known, we have found it now to be 17 units, which is now the hypotenuse. So our task now to find the cosine of theta, sine of theta, then we substitute them in the given expression that we were to find the value. So now the question was value of 4 cos theta minus sine theta. Now here it will be, we have our 4 here. What is cos theta? Cos theta, we have said here it is adjacent over hypotenuse. This is the same as, what is adjacent? Adjacent is 8. What is hypotenuse? We have found it to be 17. So cosine of theta will be 8 out of 17. How about sine of theta? Sine of theta will be, it is opposite over hypotenuse. Opposite is 15, hypotenuse is 17. So this is our this is our sine of theta. So we simply substitute. We have 4 cos of theta. Cos of theta is 8 out of 17. So into 8 out of 17 minus sine theta. Sine theta is 15 out of 17. Remember, this 4 was only on cos, so we don't put it on the value of sine theta. It is only on, it is a coefficient of cos theta. Then now from here we simplify. This is no longer trig, this is just simple operation of fractions. What is 4 times 8? We shall have here 32 out of 17 minus 15 out of 17. And then we solve. They have the same denominator, so we subtract the numerators. So here we shall have 17, here we shall have 32 minus 15. Then you press your calculator. 32 minus 15, 17. So on the numerator I'm getting 17 out of 17. Then 17 out of 17 you divide, it gives us 1. Therefore the answer is 1. Therefore 4 cos theta minus sine of theta is simply 1. And this is the answer to this problem, to this number 2 of the paper we are doing, that is the Giant Examination Board mock of 2024. So it has taken time and a little hectic, but I've tried to show every part of the solution that is important, and that's why we have taken time. Otherwise, if you have practiced in the examination, you may not write a lot of things, you just go straight to the important points. But for clarity and explanation, I have explained in detail, and that is the answer. So that is the solution to number 2 of section A. We are Vision Plus, and we appreciate you for being here. Thank you. And now going to number 3. Don't forget to like, subscribe, and share. We are Vision Plus. Number 3A says, if a function f of x equals to 2x cubed plus 6x plus 7 all over 8x squared minus 32. Find the value of x for which the function f of x is meaningless. This question is from functions, and the question is asking for the values of x that make the function meaningless. So to begin with, let me say, for a function to be meaningless, for f of x to be meaningless, in some cases we say undefined. So for f of x to be meaningless or to be undefined, the denominator should be 0. The denominator should be 0, or it must be 0. The denominator must be 0. Must be 0. So in other words, the values of x that make this function meaningless are those values of x that make the denominator 0. So to solve that, we simply need to find the values of x that make the denominator 0. So if you look at the function given, f of x equals to 2x cubed plus 6x plus 7 all over 8x squared minus 32. So our focus is always on the denominator. We need to find the values of x that make the denominator 0. So how do we get those values of x? We have said we need to get denominator being 0. Therefore, we equate the denominator to 0, irrespective of what is on the numerator. As long as you are looking for the values that make the function undefined or meaningless, do not look at the numerator. We always look at the denominator. So we equate the denominator to 0 and get those values of x that make it 0. And therefore, we shall just say 8x squared minus 32 equals to 0. This is a quadratic equation that you can solve using any method, but this is a bit direct because we can just take 32 the other side and we solve. But this is a quadratic equation that you can solve using any of the methods, from factorization to formula, completing squares, and to plotting the graph. But this question is basic, so you don't need to waste your time. Therefore, if I take 32 the other side, I will have 8x squared equals to positive 32. Then I divide both sides by 8. If I divide both sides by 8, I will have x squared being equal to 4. Then I take the square root on both sides. If I take the square root here on both sides, I will have show it here. I will have my x being equal to plus or minus 2, because the square root of any number is plus or minus, and then the exact root. So these are the values of x. Therefore, our solution, or the values of x, are x should be 2 or x should be a negative 2. These are the values of x that make this function meaningless. because if we substitute for them here, if we substitute for 2 here, 2 squared, 4. 4 times 8, 32. 32 minus 32, it gives us 0. That is, if x is that 2, if you get the denominator, we shall have 8 into 2 minus 32, and that gives us 0. If you get the negative 2, if x is a negative 2, then still we shall have 8 into negative 2, but squared minus 32. Still, this becomes positive 4 times 8, 32 minus 32 is 0. So the moment the denominator is 0, then the whole function becomes meaningless. And therefore, these are the values of x that make this function undefined. So that is the solution to number 3a. Never forget, we are Vision Plus, and comment, like, and share. Thank you. And now number 3b. Number 3b says, find the gradient of the curve y equals to 5x cubed at the point 2 and 5. The curve is defined by y equals to 5x cubed. And for us to find the gradient of the curve at any point, we need to find the gradient function. So what is the gradient function? The gradient function is dy dx, since the function is defined by y. So we need to find dy dx. This is what we call the gradient function. And this is the derivative of the curve. We find the first derivative. So we differentiate the given function of the curve to find dy dx, which is the gradient function. So our curve is y equals to 5x cubed. How do we differentiate? On differentiating, we are differentiating y with respect to x. So dy dx equals to, how do we differentiate? Using the method of powers and coefficients. We simply get the power, we lower it. And if we lower 3 and we get a number here, or a coefficient 5, then we multiply them. So here we shall have 5 times 3, and then x. Then we subtract 1 from the whole power, that is 3 minus 1. And now from there, we simplify. This now becomes equal to 5 times 3, 15, x. 3 minus 1 is 2. So we have differentiated the given function of the curve. Therefore, this is the gradient function. Therefore, the gradient function dy dx is 15x squared. Now, gradient function is important because it gives us, or it tells us, what the gradient of the curve at a given point is. So this is the general format for getting the gradient of the curve at any point. But we are given a point 2 and 5. So at the point 2 and 5, at point 2 and 5, at that given point 2 and 5, what is the gradient of the curve at that point? It means here we just say our gradient dy dx at that given point. This is the meaning of at a given point. Draw that bar. At 2 and 5 now becomes equal to, remember this is just a coordinate point. This is a point on the curve. This is coordinate on the x-axis. This one is on the y-axis. So this is x and this is y. So we just substitute for where we see x or y. But here it is predominantly x. So x is 2. So here we shall have 15. Our x is 2, but the formula says squared. So what is 2 squared? 2 squared is 4. So here we shall have 15 into 4. And then 15 times 4, 60. So the gradient of this curve at the point 2 and 5 is 60. Therefore, our gradient, which is m, is 60. And this is the solution to this number 3b. In case you would like to know more about curves and gradients, please, we have a full playlist under differentiation and its application. Find time and visit there such that these concepts are very simple for you. Otherwise, we are Vision Plus. What I'm asking from you is a simple share if these materials are adding value to your learning. Thank you. And now number 4 says, find the sum of the first 10 terms in the arithmetic progression AP 3 plus 6 plus 9 plus 12 plus it continues. The question is from series and sequences, and it is asking for the sum of the first 10 terms of an AP. It is important for you to know the formula for getting the sum of n terms in an AP series. And the formula says that the sum of n terms is equal to a half n into 2a plus open bracket n minus 1 times d, then you close. That is how we get the sum of n terms of an AP, where a is our first term. A is the first term, which you know, and our d is the common difference. And our n is the number of terms that we are dealing with. So what we just need to do is identify a, d, and n, and then we substitute them in the formula, and then we get the sum of the n terms. Now, first term is the first number of the series. Students like confusing it. They think first term is 1. No, saying first means position 1. Being in position 1 does not necessarily mean that the number is 1. So the first term is the first number of the series. And if you look up here, our first term is 3. So our A, which is the first term, is 3. How about D? D is the common difference. Common difference D is the difference between a number at a given position and the number before it. In other words, if this is our first term, we call it U1. 6 is our second term, U2. 9 is our third term, call it U3. 12 is the fourth term, U4. So for us to get the common difference D, it is just the difference between a number at a given position and the number before it. So in this case, common difference becomes U2 minus U1. And then you substitute. U2 is 6 minus U1 is 3. Then we subtract and it gives us 3. We call it a common difference because if we get like a difference of any two terms, of any two consecutive terms, we get the same number. Example, 9 minus 6, it gives us 3. 12 minus 9, it gives us 3. So common difference is the difference between any two consecutive terms, whereby you subtract the term before from the term immediately after it. So our common difference is 3. What about our n? Our n is the number of terms in question. How many terms are we dealing with? Now the question has said that we are dealing with 10 terms. So our n is the number of terms. It is 10 terms. So now that we have a, d, and n, then we can go on to substituting the formula and we get the sum. Therefore, our sum of n is 10. Our sum of 10 terms equals to, I have n. What is n? N is 10. Put 10 here into, open a square, bracket 2. Okay, 2 times a. Now we start to substitute for n. We have done that. A is 3, which is the first term. Plus, what is n? N is the number of terms in question, which is 10. So 10 minus 1 in the formula times d. What is d? D is the common difference of our terms. So our d common difference is 3. Is 3. Close. Then you close the square bracket. Now from here you need to carefully operate this. And on doing this, 10 divided by 2 is 5. So here we shall have 5 into 2 times 3 is 6. Plus, what is 10 minus 1? It is 9. What is 9 times 3? 27. So here plus 27. Press the calculator. 9 times 3 is 27. Yes. Then you close the bracket. Then you operate. This gives us a 5 into 6 plus 27. 33. And then 33 times 5. 165. So the sum of the first 10 terms of the given series above is 165. Let me compute again to say that we are sure. Yeah, I'm getting 165. So the sum of the first 10 terms of this given series here is 165. And that is the solution to example 4. Please get time and learn more about series. This was from AP, but also we have what we call GP, which is the geometric progression. Find time and learn about it. We have a list of videos on that, and that can really be important and help you a lot. We are Vision Plus, and what we request is that your colleagues and your classmates get a copy of what you are learning for a better learning experience. Thank you. And number 5 says y is directly proportional to the square of x and inversely proportional to the square root of z. If y is 16 when x is 2 and z is 9, find y when x is 5 and z is 4. This question is from proportionality and relationship of terms. And let us go through it one by one. And it is important that you have a good background of this. So it says a variable y is directly proportional to the square of x. Let's first analyze that. Y is directly proportional to the square of x. So to mathematically represent this, we shall say y is directly proportional to the square of x. The square of x is simply x squared. Okay, so y is directly proportional to x squared, or the square of x. This means that when x squared increases, y also increases. That is direct relationship. And this is the first statement, and we have mathematically expressed that. And again they have said, and the same y is inversely proportional to the square root of z. So another relationship of y is to z, or is to z. Z can be called z. So in the second case, we shall say y is inversely proportional to the square root of z, to the square root of z. That means y is inversely. If it is inversely proportional, that means we shall have 1 out of z. But they have said is square root of z. So the square root of z means you put the square root on it. So this is the square root of z, but this is the square of x. There is a difference between the square and the square root. So we have represented these two expressions separately, that y is directly proportional to the square of x, and at the same time y is inversely proportional to the square root of z. Now to combine these two into one, to combine those two into one, we can say, as the question stated, that y is directly proportional to x squared, and at the same time it is inversely proportional to the square root of z. This is the mathematical expression relating the variable y to x squared and the square root of z. Therefore, our y as a combined term is directly proportional to x squared and inversely proportional to the square root of z. This is the proportionality relationship between x squared and between y and x squared and the root of z. Now, we need to get rid of the proportionality constant, not constant, proportionality symbol. This one is proportionality symbol, and we need to get rid of it, or we need to remove it from our expression, proportionality symbol. And we remove it by introducing proportionality constant, in most cases k. This is the proportionality constant. This is the constant of relationship, proportionality constant. So we remove the proportionality symbol and introduce proportionality constant. For now, the question is not important to be seen. Let's first focus on translating it from proportionality to mathematical expression. Therefore, we shall say our y is equal to, we change the proportionality symbol to equal sign, and then we introduce proportionality constant k. So y equals to k, then x squared over z, over root of z, over the square root of z. Yes, so this is now our mathematical expression relating y to x squared and the root of z with a proportionality constant k. If we continue with the question, they say if y is 16 when x is 2 and z is 9. Let's first use those two first. Y is 16, x is 2, and z is 9. So for the case given, we are given y 16, x is given as 2, and z is given as 9. Let me confirm. Yes. So the first terms, or the first variables given, are basically to help us find the value of k. And therefore here we shall substitute our 16, which is y, substitute for where there is y, x, and z, equals to our k is what we are looking for. K is not given. The constant, we must find it. And what is x? Our x is 2, but the formula says squared over the square root of z. Square root of z is 9. Therefore, our 16 becomes equal to 2 squared is 4, 4 times k. It gives us here 4k. out of 3. Then we cross multiply, or we multiply both sides by 3. 16 times 3 is 48, equals to 4k. Then we say both sides by 4, both sides by 4. Therefore, our 12 becomes k. So our value of k is 12. After getting k as 12, then we modify the expression showing our constant of proportionality. Therefore, our y now becomes equal to 12, which is k, put in that position, x squared, which is a variable, out of z, out of root of z, for which z is also a variable. So all these are variables, but the constant relating all of them is the constant of proportionality k, which we have found to be 12. So this is now the overall expression relating these 3 different variables. Now, our question asks now, what is y when x is 5 and z is 4? So x is 5 and z is 4. What is y? So if x is 5 and z is 4, what will y be? Let me confirm. X is 5 and z is 4, correct? So y will be, we just substitute for x and z in the given expression and we'll get y. Therefore, our y becomes 12, which is the constant of proportionality, times x. Our x is now 5 in this case, but squared, out of root of z. Root of z, what is z? Z is 4. Then we press the calculator. That means we shall have 5 squared times 12, 300. So on the numerator, we have 300. And then we divide by root of 4. Root of 4 is 2. So if we divide 300 by 2, what do we get? We get 150. So therefore, y will be 150 when x is 5 and z is 4. Therefore, this is the solution. We have taken time, but this question was bulky. I have tried to explain in detail, but in the examination, based on the space available, try to summarize. For someone who had practiced, this would be just the step that they had to show. After showing this step, then someone goes straight to this and you continue with all the steps we did. Otherwise, everything I do is for the purposes of understanding and better grasping of the concept. Otherwise, this is Vision Plus, and we are doing revision of Giant Examination Board paper, which was Mathematics Mock of 2024. Please share this to your fellow students so that you learn and succeed together. Vision Plus. Thank you. Number 6 says, find the LCM of 32 and 60. There are 2 methods that I'm going to use to find the LCM. And we know by this time that LCM means the lowest common multiple. In other words, we mean the smallest number that can be divided by 32 and 60. So in method 1, we draw the prime factor table and we insert the given values. So we have 32 and 60. We draw this factorization table. I don't have a ruler, so I'm using my free hand, but it is more organized with the ruler. Find the best way to represent this. Now we start by dividing. You look for the smallest number that can divide 32 and 60. other than 1, because 1 is a factor of every number. So you look for other factors other than 1. So 2 can divide 32 and 60. 32 divided by 2, we get 16. Please get a calculator to guide you. Yes, 16. 60 divided by 2, 30. And then we assess again. Can we divide all these numbers by 2? That is 16 and 30. Yes, we can. So 2. 16 divided by 2, 8. 30 divided by 2, 15. And again, we look for, you can be ruling like this. And then again, we look for, we keep on testing 2 until 2 no longer works. Then we go to 3. So is there a number that can be divided by 2 here? Yes, 8. So you put 2. 8 divided by 2, we get 4. 15 divided by 2, there is a remainder. So we keep it as 15. And then we continue again. We look for, we test 2. Can 2 divide any number here? Yes, can divide 4. So we continue with 2. 4 divided by 2 is 2. 15 divided by 2, there is a remainder. So we keep the number the way it is. And again, 2 can be divided by 2. So we keep 2. 2 divided by 2, 1. 15 divided by 2, there is a remainder. So we keep it as 15. And then from here, we look for a number now. Since here we have come to 1, then we don't focus on it. What is the next smallest number that can divide 15? It is 3. So if you have reached 1, then you just keep on writing 1. 15 divided by 3, 5. And then we test, is there any number that we can divide by 3 here? No, 5 cannot. 1 is already in the simplest form. So we go to the next smallest number that can divide 5. And the next smallest number that can divide 5 is 5 itself. 5 divided by 5, it gives us 1. So after drawing this table now, our LCM then becomes, our LCM from here now becomes, our LCM becomes the product of all these numbers. We multiply all these numbers here. That is 2 times 2 times 2 times 2. How many are there? 1, 2, 3, 4, 5. And again times 2. Then we'll go to times 3 times 5. And then you get your calculator and multiply. And I'm getting 480. I'm getting 480 after multiplying. Confirm. 1, 2, 3, 4, 5. That is 2 power 5 times 3 times 5. So I'm getting 480. So 480 is the LCM. Or in other words, this is the smallest number that can be divided by both 32 and 60. So that is the LCM using method 1. Now to go to method 2. Method 2 is just a method of listing the multiples. Method 2, we shall get the what? Getting the multiples. This method is always hectic, and that's why it is not common. Of 32 and enter 60. So we just need to get the multiples of each. Now, what are the multiples of 32? So I'm going to write the multiples of 32 this side. Multiples of 32, okay, are numbers that we get when we multiply 32 by counting numbers. In other words, we say 32 times 1. And then we write that answer. It gives us 32. 32 is a multiple of 32 when you multiply by 1. And then again we say 32 times 2. It gives us 64. Then we say 32 times 3. Then you press the calculator. 96. And again 32 times 4, you press the calculator. 128. And again 32 times 5. You get 160. And the only problem with this is that it's hectic. Okay, now here we have the answer, and we are supposed to keep on multiplying until we get 480. That is why it is not common, but let's continue. It is good to do them together concurrently, such that when you get where they collide, like the lowest common multiple, then you stop. Common multiple. All these are the multiples of 32. These are the multiples of 60. So what is the lowest common multiple? So the common multiple is 480. And even here the multiple is 480. Yes, there are other multiples going down there, even here. But the lowest common one is 480. And therefore, our LCM is 480. That is the lowest common multiple, which this other procedure gave us in a very, very short time. So remember, in mathematics, marks are given not for the longest step, but for the correct step. So either way, using method 1 or method 2, you get the same answers. But this method 2 is very, very hectic. And that's why it is not common. People avoid it because it wastes time, and there is no proper reasoning there. Therefore, this is the solution to example 6a. We are Vision Plus, and to contribute to what we do, you simply share. Thank you. Number 6b says, expand 2x plus 1 to power 3. And the solution is, this number has very many ways of doing it. There are many methods and approaches that can be used to solve it. And I'm going to use 3 methods to solve the same number. Method 1 is operation of brackets, which is a manual method of expanding and removing the brackets. Method 2 is Pascal's triangle, also called the addition triangle. Method 3 is the binomial theorem, which is under binomial expansion. So, beginning with method 1, which is the operation of brackets, will be 2x plus 1 to power 3. Remember, if you have a number, example, if you have a number a to power 2, this implies that you multiply a by itself twice. This is a times a. And if you have maybe c to power 3, it means c times c times c. So this power here tells us the number of times we need to multiply this number, which we can call the base, by itself. So the power tells us how many times should you multiply the number in the bracket by itself. So as you can see here, it is power 3. So we need to multiply 2x plus 1 by itself 3 times. So this is 2x plus 1 power 3 is the same as 2x plus 1 times 2x plus 1, and again times itself 2x plus 1. That is the implication of what we are doing. So to make our work simpler, because to multiply all these at once, it can be hectic. So what I'm going to do is, I'm going to pick the first two brackets and I operate them, and I first get the result. So picking those two brackets, that is 2x plus 1 times itself 2x plus 1, I first multiply them and I will consider this after getting the result of these two. So let us multiply this. Remember, in operation of brackets, every term in one bracket has to multiply every term in the next bracket. And to show this, I will say this 2x here, which is the first term of the first bracket, should multiply the two terms in the next bracket. Therefore, I will have 2x into, then you copy the second bracket, that is 2x plus 1, close it, and then you go to the next term, the second term of the first bracket, which is 1. So this one here has to multiply all the terms in the second bracket. If you look at this one, it is positive, so we shall put here plus 1, then you multiply it with the second bracket, which is 2x plus 1, and then from here we expand, or we open the brackets, and then we simplify. So 2x times 2x gives us 4x squared, 2x times 1, it gives us 2x. That is the expansion of the first bracket by 2x. And then the second bracket, we have 1 times 2x, it gives us 2x. 1 times 1, it gives us 1. And then we simplify by collecting the like terms. The terms in x squared is only 1, which is 4x squared. 2x plus 2x, these are like terms, so we shall add 2x and 2x, and that gives us 4x. 1 is a term independent of x in this case, so it is a term alone, so plus 1. And we have expanded these two and we have simplified. So we can see clearly that the result of the multiplication of these first two brackets is 4x squared plus 4x plus 1. That is the result. So now that we know this value, we know this result, we can now say 2x plus 1 to power 3 will be equal to the whole of these first two brackets here is what we have got here as 4x squared plus 4x and plus 1. Those two are in this together, and then we are multiplying the result of the multiplication of the two brackets by the last bracket, which is 2x plus 1. Now again, from here, every term in the first bracket here, there are 3 terms in the first bracket. Each of these terms has to multiply each of the terms in the second bracket. Therefore, 4x squared should multiply the bracket of 2x plus 1. Also, 4x here, which is positive, a sign before any number is the sign of that number. So this 4 is positive, this 4x is positive. So we shall use here plus 4x, and then that 4x multiplies the second bracket, which is 2x plus 1. And even this one is positive, so we shall say plus 1 again into 2x plus 1. Then from here we open the brackets by the coefficients in front of them. What is 4x squared times 2x? It gives us 8x cubed plus 4x squared times 1, we get 4x squared. And then we come 4x times 2x, it gives us 8x squared. And then 4x times 1, it gives us 4x. 1 times 2x is 2x. 1 times 1 is 1. So we have open all the brackets by the coefficient that were in front or before them. I have written here 8x squared, but 4x squared times 2x should be 8x cubed, not squared. I don't know what I said on expanding this, but I've seen I wrote 2. 4x squared times 2x is 8x cubed. Yeah, that is now correct. And then from here we collect the like terms. When we collect the like terms, we look at the terms that have the same powers of x. Like here we have 8x cubed. It is the only one with x cubed here, so it is a single term, 8x cubed. And then we go to the ones of the square. There is 4x squared here, then there is 8x squared here. Those are like terms. We add them, we shall get 12x squared. And then we look for the terms in x. Here we have 4x plus 2x, it gives us 6x. So here we shall say plus 6x. And then we look for the terms independent of x. Like in this case, this one is independent of x, so plus 1. So this is the answer, simply because we have multiplied the term or the base 2x plus 1 by itself 3 times, and this is the result we have obtained using method 1. And even the rest of the methods are going to give us the same answer as this if we work accurately. So this is the answer to example 6b using the method of operation of brackets. It is important for you to follow and see how we do the Pascal's triangle and even the binomial theorem, because the examination can be specific. They can say expand this using Pascal's triangle or expand this using binomial theorem. So in that case, if you do not adhere to the given method, your solution can give you the right answer, but they will not mark it because you are using a different method than the one the examiner intended. So that is the solution using method 1. And as a reminder, we are Vision Plus, and if the materials are helping you, then let them also reach your friends and classmates. Thank you. Let us see how we can solve the same number 6b using method 2. I said in the previous video that method 2 is Pascal's triangle, and in some books you'll find that it is called addition triangle. So in case it comes in your exam that expand using addition triangle, please, it is the same as Pascal's triangle. And before I go into the question, I believe you have a background of the Pascal's triangle, and the Pascal's triangle is in this format. Its main aim is to give us the coefficients that we need to use in our expansion. So the format is, I will have here coefficients, I'll put here coefficients, and then the coefficients correspond to powers, and the powers as well correspond to the coefficients. If the power is 0, the coefficient is 1, and you know that any number to power 0 is 1. That is the same concept employed here. Any number to power 0 is 1. So if the power is 0, then we have a single coefficient 1. And how do we get the rest of the coefficients? Like for example, if the power is 1, if the power is 2, 3, and 4, it goes on. So if the power is 1, now the coefficients, when we are employing Pascal's triangle, we say, after writing 1 here, for the power of 0, the next coefficients will be, just write 1 and 1 on the sides. Don't write anything directly on 1, which is directly under 1. So we write here and here. That is, these are the coefficients when the power is 1. Coefficient will be 1 and 1. What if the power is 2? What are the coefficients? We simply add. To write a coefficient, we will say 1 plus 1 is 2. So we write 2 here. And then again we put 1 on the opposite side. We guard it with 1s. 1 here and 1 there. So if the power is 2, the coefficients that we can derive from Pascal's triangle are 1 to 1, corresponding to the terms. This means that our answer, if the power is 0, we shall have 1 term. If the power is 1, we shall have 2 terms. If the power is 2, we shall have 3 terms. But if the power is 3, we add 1 plus 2, 3. 2 plus 1, 3. And then again we guard it with 1 and 1. So if the power is 3, coefficients from Pascal's triangle are 1, 3, 3, 1. And they are 4. That means we shall have 4 terms. And if you look at our question, we have the power of 3. So someone could just stop here, because this is what the question wants. But for your purposes of understanding, let me add if the power is 4. If the power is 4, the coefficients become 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. Then again we put 1 on the opposite sides. So if the power is 4, we shall have 5 terms. And these are the coefficients. 1, 4, 6, 4, 1. And it continues. Okay, if the power is 5, we simply say 1 plus 4, 5. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And then you put 1 and 1 at the end. So if the power is 5, there are 6 coefficients on that number. But without wasting time, we have seen clearly that our power n, these powers are the n. Our power n is 3. So we shall stop here. And these are the coefficients that we are going to use later. So we have seen how to deduce the coefficients based on the power. If the power was 4, then we will take the coefficients corresponding to 4 and even 5 depending. So we have got the coefficients. Now after getting the coefficients, how do we now integrate the coefficients to assist us in expanding that number? So you copy the number equals to, this is the number. Let me close out the coefficients for now, leaving that part. Remember, any expansion is in the form of a plus b to power n. And in this case, a is the first term. And if we are to compare, our a corresponds to 2x, our b corresponds to 1, and our n corresponds to 3. And the general expansion in the form of a plus b to power n with Pascal, we have said that in your previous learning that the powers of the first term, which is a, the powers of the first term a will start from n. So here we shall have a to power n. And the powers of the second term b will start from 0. So we shall have b to power 0. Now, the powers of a are going to decrease from n up to 0. The powers of A will decrease. Powers of A, they will decrease from n to 0. But the powers of B will increase. They will increase from 0 to n. These are the powers of B. So now from here, our A to power n, now it means in the next term, the powers of A will decrease by 1. So we shall have A to power n minus 1, but the powers of B will increase by 1, giving us 0 plus 1. And the third term, the powers of A will again fall by 1. So we shall have A to power n minus 1 minus 1. That gives us minus 2. Then for B will increase to, they will increase to 2. And the next term again, the powers of A are again going to fall by 1. So we shall have n minus 3. Then the powers of B will increase to 3. And this continues depending on the value of n until the power of A is 0 and the power of B now has increased to n. So the powers of A fall from n to 0, but the powers of B rise from 0 up to n. They are opposite. And now to integrate this, I've taken time on that, but I believe you have a background of that. Now to integrate that, I will now have 2x plus 1 power 3 equals to, we just follow this just to guide us. What is our A? Our A corresponds to 2x. So here we shall have 2x plus 1. Oh, sorry. Our A is 2x. So we shall have 2x to power n. Our n is 3. And then our B is 1 to power 0 plus. Again, our A is 2x power n minus 1. N is 3. 3 minus 1 gives us 2. And then our B, which is 1, rises to a power of 1. And then plus. Our 2x again falls by 1, because here we shall say n minus 2. That is 3 minus 2 to gives us 1. Our B, which is 1, increases by 1. Its power increases by 1 to form 2. Plus our A again decreases by 1. 2x, which is n minus 3. N is 3. 3 minus 3 is 0. And then B, which is 1, its power rises to 3. So this is the general format of the expansion. Now remember our n was 3. And if n is 3, we shall insert these coefficients 1, 3, 3, 3 in that order, and they correspond to the terms. That means here we shall have a coefficient of 1, and here we shall have a coefficient of 3, here we shall have a coefficient of 3, and then lastly we have a coefficient of 1. That is how we employ the coefficients from the Pascal's triangle. So from here, I have inserted the coefficients and I've followed the rule of expansion, where the powers of A decrease from n to 0, but the powers of B increase from 0 to n. Now let me cover that, and then we simply simplify this. What is 2x power 3? That is 8x cubed. 2 power 3 is 8, x power 3 is x cubed. Then time is 1, we still have 8x cubed. 1 to power 0 is 1. 1 times 8 is still 8. It makes no difference. Also here, 1 to power 1 is 1. And if we multiply 1 by this, it makes no difference. So what is 2x power 2? That is 4x squared. 4x squared times 3, it gives us 12x squared. And then here we have 1 power 2, which is still 1. So this makes no change to our expression. 2x to power 1 is 2x. 2x times 3, it is 6x. So here we shall have plus 6x. And then 2x to power 0 is 1. 1 to power 3 is 1. So 1 times 1 times 1 is still 1. So here we shall have plus 1. Plus 1. And this is the answer when we are using Pascal's triangle to expand that given question. And if you go back and review or look at the answer that we got in method 1, it is the same answer. That means that the two methods or all the methods give the same answer, just that we have different ways of applying each method. So this is the answer. If you have a knowledge of the method we are going to, you can try it out and then we confirm in the next video. This is Vision Plus, and thank you for being part of the chosen people to get these resources. Let us see how we can solve 6b using method 3, that is the binomial theorem, to expand this question in 6b. Before I copy the question, there is a formula for binomial theorem. There are actually two, but one of them applies to any given number that we need to expand, any expression. But one of them is limited in that you need to manipulate the given question. So I will use the one which is universal and solves every expansion that we can be given. That is, if you have a plus b to power n, some books they say x plus y to power n, a and b are variables just like x and y. So if you have a number, an index number in this format with two or more terms, like in this case a plus b, binomial theorem says that the expansion of this becomes a to power n. Okay, that means here b is to power 0, and the first term is over 0 factorial. And then how do we get the second term? So we say plus. Now the second term we drop the power of a, which is n, drop it here, so we shall have n and then a. We have dropped the power of a. Now the new power of a becomes n minus 1, and then we write b. The new power of b is 0 plus 1, which is 1. I may not show it. 0 plus 1 is 1. And then we divide the second term by 1 factorial. And then we go to the third term. For the third term again, we drop the power of a, which is n minus 1. So if we drop n minus 1, it finds a coefficient n here. So we multiply them. So we shall have n, which was already there, times the new power of a that we are dropping, which is n minus 1. We multiply them in that manner. A. Now the new power of a in third term becomes n minus 2. Like if you have n minus 1, then you subtract 1 again from it, it gives us n minus 2. That's why here we shall have n minus 2. And then the powers of b will again increase by 1. So 1 plus 1 is 2. So this term now is out of 2 factorial. What have you noticed? The factorial number on the denominator is basically a power of b. So b to power 0 divided by 0 factorial. If b has a power 1, by 1 factorial. B has a power of 2, by 2 factorial. That is a simple logic for you to remember the denominators in terms of factorial. Plus, remember this continuous depending on n. So it continues until time is reached when the power of a is 0. As you can see here, the powers of A are falling. So it reaches a point when A has a power of 0 and B has a power that has reached n. The powers of B have increased to n. You have a knowledge on that. And then from here we divide by the power of B still, which is n. So divide by n factorial. N is the power given. If it is 1, we stop here. If it is 2, we stop here. If it is 3, we look for the next term, as in our question there. So this is the formula for binomial theorem or binomial expansion. Therefore, if we look at our number there, we need to compare our number to this given expression. So on comparing, let me try to save time, but I believe you're understanding it. On comparing, we see A corresponds to 2x, A is 2x, B is 1, and n is 3. So we simply need to substitute for A, B, and C in the given expression of the formula of Pascal's triangle. Thus 2x plus 1 power 3 equals to, you press these factorials on the calculator. 0 factorial. For you to get the factorial, depends on the calculator, but you press shift and a button on your calculator which has x factorial. So you press shift, then you press this button, it will give you factorial. So b to power 0 is 1, so we can neglect that, it makes no difference. 0 factorial is 1, so a number divided by 1 is that number. So basically we shall have a, which is 2x, to power n. What is n? N is 3. B to power 0, b is 1, to power 0 is 1, it makes no difference. Sorry for that. And denominator is going to be 1, 0 factorial, so it makes no difference there. Plus, what is our n? Our n is 3. What is our a? 2x. Power n minus 1, n is 3. 3 minus 1 is 2. Then, what is b? b is 1, to power 1. Divide by 1 factorial. If you press your calculator, 1 factorial is 1. So if you divide this number by 1, it makes no difference. So we just leave it. Or it is that number exactly. Plus, what is our n? Our n is 3 into, what is n minus 1? N is 3. What is 3 minus 1 is 2. So there we get 2. I may not show it for the interest of time. But you have heard that n minus 1 means 3 minus 1 gives us 2. A, what is our a? Our a is 2x. I'm putting it in a bracket because there are 2 terms. And even if it is 1 term, putting it in the bracket makes it better for you to avoid errors in terms of sign. Power n minus 2. What is our n? Our n is 3. 3 minus 2 is 1. And then b is 1, but b to power 2 here. Divide by 2 factorial. You press the calculator. 2 factorial, I'm getting 2. So I now divide this by 2. All these were out of 1, which make no difference. And then plus now the third term. Third term again, third term will be, it will be n, which is 3, into n minus 1, which is 2, into n minus 2. Yeah, into n minus 2, which is 3 minus 2 gives us 1 here. And then we put our 2x, which is a. Now the power goes to 0 because it becomes n minus 3. N minus 2 here, the next time is n minus 3. The next time is n minus 4. So 3 minus 3 is 0. And then we have our b, which is 1. To which power? B now is to power 3. To power 3. Then now here we divide by 3 factorial. What is 3 factorial? 3 factorial is 6. So we divide by 6. And then from here we simplify. From here now it is just a matter of simplifying. There's no more binomial. What is 2x power 3? It gives us 8x cubed. What is 2x squared? 4x squared. 4x squared times 3 gives us 12x squared. What is 2 times 3 times 2? It gives us 2 times 3, 6, 12. 12 divided by 2, it gives us 6. So here we shall have 6x. 1 to power 2 makes no difference. Plus, again 2 times 3 times 1. 3 times 2 times 1. This is to power 0. This one here is to power 0. So it means here we shall have 2 times 3. This one is to power 0, so this one gives us 1. So here we have nothing. So 2 times 3 is 6. Yes. 6 divided by 6, it is 1. Because here this is 1, this is 1. 1 times 1 is 1, times 1 is 1, times 2 is 2, times 3 is 6. 6 divided by 6 is 1. And this is the final answer. And if you go back and you look at the other methods that we did, the first two methods, you'll find that the answer is the same. So this is the answer using the binomial theorem. I did all the three methods simply because if the question is specific that use binomial theorem to expand this, then you can be in position to do it and you get your answer appropriately. This concept needs a lot of practice because I'm sure somewhere here in getting our last term, you might have been a little confused because I've not written the expression here. But for you to understand better and have a deeper background and foundation on binomial expansion, I encourage you to go to our Senior 3 playlist on binomial theorem and you learn from there. This is Vision Plus, and we appreciate you for being here. Looking at number 7, we are given two matrices, that is matrix A and matrix B. Matrix A is a 2 by 2 matrix. Even matrix B is also a 2 by 2 matrix, simply because each has 2 columns and 2 rows. And our question says, find the determinant of P, and given that P is 3A plus 2B. So the solution to this would be, before we find the determinant, let us first find matrix P. After getting the matrix P, then we find its determinant. And we are given a small expression to find P. They have said that P, they have said matrix P equals to 3A plus 2B. So to find it, we simply need to substitute for matrix A and B as given. And this becomes 3 times matrix A. Matrix A had 1 and 2 in the first row, and then in the second row we have 5 and 0. Remember, these are rows across, and then down we have the columns. So we are multiplying a matrix by a scalar. 3 is a scalar number in this case, plus 2 times matrix B, which is 2, 3, 1, 5. And then we operate To do this, the scalar here, which is 3, should multiply every number or every member of the matrix. So we shall say 3 times 1, keeping their positions. 3 times 1 to gives us 3. 3 times 2 to gives us 6. 3 times 5 we get 15. 3 times 0 we get 0. And then plus we also multiply the entries or the members of matrix B by the scalar number 2. So 2 times 2 we get 4. 2 times 3 to gives us 6. 2 times 1 we get 2. 2 times 5 we get 10. We have operated 3a plus 2b. Now what we need to do is to add them. We add this to that. Remember, when we are adding matrices, we add the corresponding elements or members. 3 is in the first row, first column. Even here 4 is in the first row, first column. So we add by position. Therefore, we shall say 3 plus 4. Then you shall say 6 plus 6. Then you shall say 15 plus 2. And then you shall say 0 plus 10. We just add the corresponding position. And even the same applies to subtraction. You subtract by position just. It is a multiplication that is somehow different. Then you add the corresponding terms. So here we shall have 7. Here we shall have 12. Here we shall have 17. Then here we shall have 10. So this is our matrix P. But remember, the question was asking for the determinant of P. So we have P now. What we need to find is the determinant that the question wants. How do we get the determinant? Determinant of P, which we write as det of P. This is simply determinant of P or any other matrix. So determinant of P is given as if you look at this, it is a 2 by 2 matrix, and members in this horizontal position, we call this region major diagonal. That is major diagonal. So it is simply product of major diagonal and then minus product of minor diagonal. Which one is the minor diagonal? The opposite. This is the minor diagonal. So this is our minor, and then this is our major diagonals. Those are the diagonals. So simply, our determinant of P now becomes 7 times 10 minus 17 times 12. Simply like that. Then you place your calculator. This is 70 minus 204 on pressing the calculator. And then you subtract. So I'm getting negative 134. So this is the determinant of matrix P, and That is the solution to number 7. Thank you. Number 8, we are given a question from SATS, and it says express root 3 minus 2 over 2 root of 3 plus 3 in form of p plus q root 3. So this is from division of SATS, and the solution to it would be, we are given root 3 minus 2 all over 2 root of 3 plus 3 equals to, the first step is to rationalize it. This is, we shall rationalize it. That is a process called rationalization. And here what we do, we simply want to remove the square root sign from the denominator. The square root sign is what we call the SAT. This root sign is actually the SAT. So for us to remove the square root sign from the denominator, we need to rationalize it. And how we rationalize it is, we get the conjugate of the denominator. We get the conjugate of the denominator. So from here, I'm going to say conjugate. Conjugate is only got for the denominator. Do not even look at the numerator. So the conjugate of the denominator is obtained by changing. We change the sign which is in between these two numbers. That means our conjugate becomes 2 root of 3 minus 3. This is our conjugate. So after getting the conjugate, then you multiply the numerator and the denominator both by the conjugate of the denominator. This is the numerator. I believe you know that by now. This one is the numerator, and then the number down is the denominator. Please, you know that. So after getting the conjugate, then you copy your question, that is root of 3 minus 2 over 2 root 3 plus 3. You just say equals to, then you show your multiplication. So we shall say this is our numerator, and then I multiply it by the conjugate of the denominator, that is 2 root of 3 minus 3 all over, I get the denominator which is 2 root 3 plus 3 time is the same conjugate of the denominator which is 2 root of 3 minus 3. And then from here we go into multiplication. I believe you have a background knowledge, and in case you don't, please visit our list of videos in Senior 2 Mathematics. We have solved that one clearly there. So from here, you multiply. I may not show all the steps, but you will understand. We shall say on the numerator, we shall get root 3 times 2 root 3. So root 3 times 2 root 3, it gives us 2 root of 9. There are a lot of rules, and they are simple ones that you will understand from Senior 2 Mathematics after visiting there and making good notes. And then again root 3 times negative 3, it gives us negative 3 root 3. Remember, every term in the first bracket multiplies each of the terms in the second bracket. So root 3 has done that. Then we come to negative 2. Negative 2 times 2 root 3, it gives us negative 4 root of 3. Negative 2 times negative 3, it gives us positive 6. So we have simplified the numerator. We have operated the brackets. all over. Then we come to the denominator. This is basically a difference of two squares, but it's not easy to see, so let's just keep on multiplying it. 2 root 3 times 2 root 3, we get 4 root 9. 2 root 3 times negative 3, we get negative 6 root of 3. And then 3 times 2 root 3, we get positive 6 root of 3. 3 times negative 3, it gives us a negative 9. We have again operated the denominator. Now let's simplify. What is root of 9? That is 3. 3 times 2, it gives us 6. Right? Here we get 6. Because root of 9 is 3 times 2, 6. 6 plus 6, they are like terms. It gives us 12. And then here we have negative 3 root 3 minus 4 root 3. Operating that gives us negative 7 root of 3. Because it is negative 3, negative 4, and they have a common side. So that is the simplification of the numerator over denominator. This and this are cancelling because this is negative 6 root 3 and positive 6 root 3. So these are going to cancel out. And then here we shall have 4 times root of 9. Root of 9 is 3. 3 times 4. So here we shall have 12. This and this have cancelled. So we shall say 12 minus 9. And then on further simplifying that, we shall get the numerator is already simplified. Keep it the way it is, over 12 minus 9 is 3. And then remember we were asked, this is the answer, but remember we were asked to write it in a certain form, in a form of p plus q root 3. So we are seeing root 3 already here, so we are almost there, that we write in the form of p plus q root of 3. So simply we need to distribute the denominator. This is the same as 12 out of 3 minus 7 out of 3, and this 7 has a root 3 attached to it. And then we simplify where possible. 12 divided by 3, get 4, minus 7 out of 3, and then there's a root 3 attached to it. Whether you write it up or on, or if it is between 7 and 3, it is the same thing. So we have distributed the denominator to look in this form. So our expression now is, it is now in the form of p plus q root of 3. And if we compare, on comparing, because in some question papers they say and hence deduce for p. If we compare, this p here corresponds to 4. So we can just say p is 4. And then q is a number before root of 3. And a number before root of 3 here is, it is 7 out of 3. But remember, a sign before a number is the sign of that number. That means our q here is negative 7 out of 3. So this is the answer. This was basically the answer required. And on comparing, this is p and this is q to this number 8 of the Giant Examination Board mock of 2024. Yeah, a quick reminder, share these materials with your friends and colleagues such that they benefit from the work of Vision Plus. Thank you. Number 9 says simplify this given expression. If you look at this expression, we have numbers raised to powers. So this question is from indices. We have a number, like here we have 8 to power 1 out of 3, and the rest of the numbers with their respective powers. For us to simplify this, we need to express the bases in terms of powers. Like we need to express 8 in terms of powers, we express 4 in terms of powers, we express 32 and also 16 in terms of powers. That is the first step. So this is the same question that I've written here to save our time. So the first step that we need to apply here is to express all the bases in terms of powers. So what is 8 in terms of powers? In other words, what number can be multiplied by itself for a given number of times to give us 8? The simplest way in most cases is for you to sketch a prime factor table. You can put here 8. Actually, you do it only for one number. You do the prime factor table for each number. You can put here 8. Then you say by 2, 4, by 2, 2, by 2, 1. Therefore, 8 is the same as 2 times 2 times 2. We are multiplying a number 2 by itself. In this case, 3 times. So, therefore, in the index form, 8 is the same as 2 to power 3. Simply because we are multiplying the base 2 by itself 3 times. So I've done this, and you can do it for any other number. But for the given example, and since you are candidates, this question is very simple. I will not show this for all the given bases. So 8 in terms of powers, it is 2 to power 3. But remember that 8 is raised to power 1 out of 3. So you keep the original power in that format. Time is 4. What is 4 in terms of powers? 4 is the same as 2 squared. I'm not going to show that, but if you represent it on the prime factor table, you will be able to get that 4 is the same as 2 squared. And then the original power was a half. Keep it there. Over, all of them over. What is 32 in terms of powers? If you draw the prime factor table to guide you, you will find that 32 in terms of powers is 2 to power 5. If you multiply 2 by itself 5 times, it gives you 32. And then we keep the original power, which was 1 out of 5. That is the original power. Have a network 1 out of 5. And then time is, what is 16 in terms of powers? 16 is the same as 2 to power 4. This is 2 to power 4. If you multiply 2 by itself 4 times, it gives you 16. And then the power is 1 out of 4. So we have expressed this in terms of powers. We have expressed the basis in terms of powers. Then we simplify. Remember, from your indices, there is a law that says if a number with a power is raised to another power, then the new power is simply the product or the multiplication of those two powers. Therefore, we need to multiply the powers on each of the bases. So for the first case, we shall have 2 power 3 times 1 out of 3. You simply multiply those two powers. Time is 2 raised to power 2 times 1 out of 2. Then we divide all of them by 2 raised to power 5 times 1 out of 5. And then time is on the denominator here. We have 4 power 4 times 1 out of 4. So the law says if a number with a power is raised to another power, the new power is the multiplication of the two powers. Then from here, you press the calculator to multiply those powers. So here we shall have 2 power. What is 3 times 1 out of 3? It is 1. The 3 and the 3 will cancel. So here we shall have 2 to the power 1 times 2 times a half on the power. It is also 1. So this is also 2 to the power 1 over 2. 5 times 1 out of 5. The 5 and the 5 cancel. So we shall have 1 times I think I made a mistake here. If you notice it, this should not be 4 here, right? This was 2. This number here was supposed to be 2. It is not 4. So let me just erase only that part. If you notice that, thank you. It is supposed to be here 2 raised to power 4. From here, just raised to power 4 times 1 out of 4. So the 4 and the 4 cancel. So here we shall have 2 power 1. And then we multiply. Remember, on the numerator here, we have 2 numbers of the same base that we are multiplying, right? 2 and 2 is the same base. The powers do not necessarily have to be the same, but as long as the bases are the same, then we add the powers. So here we shall have 2 power 1 plus 1 over, still it is the same expression on the denominator. So here we shall have the same base 2, so we add the powers. So here we shall have 2, 1 plus 1. So on the numerator, if we add 1 plus 1 on the power of 2, it gives us 2 out of 2 to power 2. If you look here, we are dividing 2 numbers of the same base. The base is 2 here and the base is 2 on the denominator. The powers can be the same or they can be different. But as long as the bases are the same, we subtract the powers. So from here, we shall just have 2, then we subtract the powers. So 2 to the power 2 minus 2. And this here gives us 2 to the power 0. Any number to power 0 is 1. So the answer is 1. Alternatively, even from somewhere here, someone can take a different route from here. Someone can just say, what is 2 to the power 2? That is 4. On the denominator, it is also 2 to the power 2, which is 4. 4 divided by 4, it is also 1. Or someone can say, okay, my base is 4, and each one has a power of 1. So it still gives us 4 raised to the power 1 minus 1, which is 4 to the power 0, and that still gives us 1. So there are very many approaches as we narrow down. So this is correct. If somebody had done this, this would also be correct. So this is the answer and the solution to number 9 of the Giant MOOC Examination Board Mathematics of 2024. And this is Vision Plus. Number 10 says, solve for x in log of 5x minus 4 equals to log of x plus 1 plus log of 4. This question is from logarithm. And let us quickly review the laws of logarithms. Law 1 says, if you have log of a number, say the number is a, plus log of another number, say b, as long as they have the same base, then the result becomes log of a times b, which is log of ab. So if you are adding logarithms of the same base, then you multiply their numbers. Law 2, if you have log of a number, say a, minus log of another number, say b, as long as the two logarithms have the same base, then the result here becomes log of a over b. We divide. That is the second law. Another law is if you have log of a number to a given power n, regardless of the base, if you have log of a number raised to a given power, then that expression is the same as lowering that power, that index number. So we lower that exponent of the number. So we shall have here n log of that number a. So we simply take the power of the number and we put it as a coefficient of that log. This is the third law. The fourth law, in most cases it is said to be a property, is if you have a number, like for example, if you have log of a number, say a to maybe base b equals to c. If you have this as an expression, okay, you have log of a number a and that log is to base b equals to c, then this simplification is the same as, this can also be written the same as, by definition, remember, log of a number, which is a in this case, so log of a number a is a number c to which when the base b is raised, it gives us that number a. It is a little confusing, I know that, but it's simple. You just take the result c, make it a power of b, and we should give you a. That is, if we take c as a power of b, so b to power c equals to a. That is the meaning. So this is the fourth law, or others consider it a property. In case you don't have sufficient knowledge on this, please go and look at our list of videos in Senior 3 Mathematics. This is actually the first topic that we did in Senior 3 Basic Mathematics. I've taken much of your time, but these laws are very important for practice. Visit our videos and do all those examples that we have explained. Now coming to our number. Our number, let me copy it here. We have log of 5x minus 4 being equal to log of x plus 1, and then on this side we have plus log of 4. Should be a small letter, please. Log of 4. So let me close everything up here now, including that property. You need to find time and think about this property. It disturbs. Now on this side we have one term, so let us keep this one term just the way it is. That is 5x minus 4. The whole of that is a single term equals to. On the right hand side of this equation we have addition. And remember we said if we're adding logarithm of the same base, then we multiply their numbers. Since the base here is not indicated, we assume it to be base 10. It is base 10, that is the natural log. Therefore here we shall say log of, and then we multiply these numbers. So we assume this is a, the whole of that is a, and 4 is b. So we shall have a, which is x plus 1 times 4. So I can start with 4 times x plus 1. Put both in the bracket like that. Therefore here we'll have log of 5x minus 4 being equal to, and then we simplify that. Always keep it inside a bracket. So here we shall have 4 times x, we shall have 4x, we shall have 4x plus 1, 4x plus 4, because it is also 4 times 1. Now this is where we are. From here someone can take a different path. There are many paths or many ways someone can work out this. Way 1, just call it, not necessarily, but let me call it a method 1. Here someone can say, since I have two logarithms on different sides of the equation and they have the same base, that implies that their numbers are equal. We have only two logarithms on opposite sides of the equation with the same base, so we say their numbers are equal. Therefore, here someone can just say, therefore 5x minus 4 is equal to 4x plus 4. This one now is linear. So we collect the like terms. So here we shall have 5x minus 4x equals to this 4 which was here. If this 4 crosses the equal sign, it becomes positive. So plus 4. 5x minus 4x is x. Therefore, our x equals to 8. This is the answer. X is 8. Taking path 1. What if someone wants to take another method? Not necessarily a method, but is a way. Let me call it method 2. Now from here, someone can put them on one side of the equation so that we shall have a log of 5x minus 4. If you carry this logarithm to the other side, it becomes negative log of 4x plus 4. And then you will be left with 0 on this side. Remember, we are left with 0. Now here we are subtracting two logarithms of the same base. What do we do to the numbers? We divide, remember. So we're going to divide. We shall have 5x minus 4 out of 4x plus 4 equals to 0. Now from here, we are going to apply the other property I said, which is log 4. That log of a number is the number log of a number is a number which, when the base is raised, gives us that number. So from here, what is our base here? We say that if the base is not given, it is base 10. So if we take 0 as the power of 10, it should give us the whole of this expression here. Therefore, if we take 10 to power 0, it should give us the whole of that expression, which is 5x minus 4 out of 4x plus 4. What is 10 power 0? That is 1. If we cross multiply this out of 1, if we cross multiply, we shall have, remember this is 1. So 1 time is, we cross multiply, so multiply this and multiply that. So this is 1 up and also 1 down. Therefore, 4x times 1, we shall have 4x plus 4 being equal to 5x minus 4. This is the same step here. This step and this step are the same. It is simply that they have the same terms but on opposite sides of the equation. Then we solve it. You choose where to have your x. So let me carry my x this side, so that I have 4x minus 5x equals to negative 4. If I take this 4, that it becomes also negative 4. 4x minus 5x is negative x equals to negative 8. Then you say both sides by negative 1, both sides by negative 1. Remember, you are looking for x, so our x here becomes positive 8. The same answer that we obtain using approach 1. So that is the solution to number 10A. And as a reminder, this is Vision Plus, and if you have learned something so far, then share this material with your friend or your classmate such that they can find the same information and you pass together. Thank you. Number 10B says, solve for x in 5x power 4 equals to 80. We are given 5x power 4 equals to 80. There are many approaches anyway to a given equation, but in this case, since we are looking for x, we need to make x the subject of the formula. So I can take away 5 from here by dividing both sides by 5. So if I divide 5 by 5, I get 1. So here I'll be left with x power 4 equals to, what is 80 divided by 5? This is 16. Press your calculator. Don't suffer. This is 16. After getting 16, we now need to find x. So what we can do here is we can take the fourth root of this number, simply because this is to power 4. And if you look at this power, it is even. It is an even power. That means whether x is positive or negative, if you raise it to power 4, it gives us a positive number. So from here, I'm going to take the fourth root on both sides, 16. So I'm going to take here the fourth root, put here 4, and I also take here fourth root of 16. Fourth root simply means the power of x that we're introducing is 1 out of 4. So the fourth root and the power 4 are going to cancel out, and therefore we shall only be left with x as the subject of the formula. What is the fourth root of 16? The fourth root of 16 is just the same as 16 raised to power 1 out of 4. Just like root of a number, maybe a is just the same as the half power of that number. So the fourth root of 16 is 16 raised to power 1 out of 4. Remember, if you are taking nth root, of a number, and the nth root is even, is an even number like 4. The root of any even number, I'm not meaning 16, I'm talking on the nth root or the root number. This is root number 4. So 4 is even. Therefore, we shall have plus or minus. If you press the calculator and you press 16 to power 1 out of 4, that gives you 2. So here we shall have plus or minus 2. So as long as the number we have here is even, we shall have a plus or minus. But if the number is odd, then we shall have only plus, or depending on the sign, which is before the 16, before the root sign. So if n is even, like if it is 2, 4, 6, 8, these are the even numbers, then we shall have plus or minus. But if n is odd, like for example 3, 5, 7, 9 to continuous, then our answer becomes, it is strictly positive for the root, but also depends on the sign before the root. So the nth root that I was meaning is this nth root of the number a. This is nth root. Yeah, so this is the answer. I know most people will just take the fourth root of 16 and they get 2. But remember, 4 is an even number. So if it is an even number, you put plus or minus. If this power was 6, you still would put here plus or minus, and then we get the sixth root of 16. But if this one was an odd number like 5, 7, then we just take the 7th root or the 5th root of 16, which will be positive. and other signs in the question can alter that. So this is the answer for number 10B. If you have another approach to it, you can let us know in the comment section, but that is the absolute approach that you can get. Otherwise, this is Vision Plus, and share these materials with your colleagues such that they can learn. Thank you. We are now starting section B. We have completed section A, and section B should start from number 11, not 10. So section B, number 11, we are given complex number Z1 as 5 minus 4i, and complex number Z2 as 3 plus 4i. The question says, find Roman 1, Z1 times Z2, Roman 2, Z1 over Z2. So this question, Roman 1 is from multiplication of complex numbers. Roman 2 is from division of complex numbers. We have a full playlist on complex numbers. Visit there for more knowledge and a deeper understanding. Otherwise, in this number, I will point out important concepts that we need to apply here. So for part A, Roman 1, Z1 times Z2 becomes equal to, we substitute what is Z1. Z1 is given as 5 minus 4i. Substitute there. Times Z2. I'm going to keep them in brackets strictly. So this is Z1. Z2 is 3 plus 4i. And then from here we multiply. Remember, every number in one bracket multiplies every number in the second bracket. So to simplify this, I will say this 5 here will multiply all the terms in the second bracket. So I will say 5 into 3 plus 4i. Yes. And then the second term of the first bracket, that is negative 4i, should also multiply the terms in the second bracket. So I will put here negative 4i as a minus 4i into then 3 plus 4i of the second bracket. And then from here we multiply. 5 times 3, 15. 5 times 4i, it is 20i. Press the calculator. We have operated the first bracket. The second bracket, we have negative 4i times 3. That gives us negative 12i. Again, negative 4i times 4i. That gives us positive 16i squared. 4 times 4, 16. Negative times positive, negative. I times I squared. And then we simplify. 15 is a real number of the real part, plus we operate 20i minus 12i, we get positive 8i, and then minus 16. What is I squared? I squared is a negative 1. That is the purpose of complex numbers. I squared is negative 1. This is what we call Euler's property. The list of videos will guide you very well. Please visit there. So instead of I squared, we put a negative 1. Therefore, we shall have negative 16 times a negative 1. It becomes positive 16. Positive 16 plus 15. We shall get 31 because this is now a real part. This one has become a real part. So 15 plus 16, we shall get 31 plus 8i. and this is the answer of the multiplication. Let us now go to Roman 2, which is Z1 out of Z2. That is the division now. So for Z1 out of Z2, we simply substitute what is Z1. Our Z1 is 5 minus 4i, but we are dividing it by Z2, which is 3 plus 4i. Now, this is division of complex numbers. In division of complex numbers, we get the conjugate of the denominator. So if you look at the denominator, it is 3 plus 4i. So we get the conjugate of 3 plus 4i. If you are getting the conjugate, we simply change the sign in between here. If it is a positive, then we'll make it a negative. So we shall have 3 minus 4i. But if it is a negative, you change it to positive. That is how we get the conjugate. So this is the conjugate. After getting the conjugate, remember, why are we getting the conjugate? We do not need to have I on the denominator. So if we multiply the denominator by its conjugate, it becomes a real number. So we don't want the imaginary part on the denominator. We want the denominator to be strictly real, the real part of the complex number without imaginary part. So we get the conjugate of the denominator, and then we multiply the numerator and the denominator by the conjugate of the denominator. That is sort of rationalization. So now from here, this is the same as 5 minus 4i times 3 minus 4i over 3 plus 4i times the conjugate, which is 3 minus 4i. After illustrating this, then the rest now is multiplication. I may not show a detailed approach to multiplication because we did it already. I'm going to skip steps. So we shall say 5 times 3. This 5 times 3, I get 15. 5 times negative 4i, I get negative 20i. I'm done with 5. I come to negative 4. Negative 4 times 3, I get negative 12i. This is negative 4i. And then again, negative 4i times negative 4i, I get positive 16i squared. I've multiplied the numerator. Going to the denominator, 3 times 3, it is 9. 3 times negative 4i, it is negative 12i. 4i times 3, positive 12i. 4i times negative 4i, this is negative 16i squared. But on the denominator, this is a difference of 2 squares, and you can use a short approach, and it's the same if you multiply it as we have done. Then we simplify both the numerator and the denominator. So for numerator, I will have here 15, negative 20 minus 12, negative 20i minus 12i, that is negative 32i, plus 16. What is our I square? Our I square is a negative 1. This is the foundation, and we call it the Euler's property. Over this 12 and this 12 are cancelling out, so it is over 9 minus 16. I squared again is a negative 1. Then we simplify this further. On simplifying it further, we shall have this 16 here becomes a negative. 16 times a negative 1 is a negative 16. 15 minus negative 16, we shall get a negative 1 on the real part. Then minus 32i over, this one becomes positive. Negative 16 times a negative 1 is positive 16. 16 plus 9 is 25. So this is the answer of z1 divided by z2. Or alternatively, someone can distribute the denominator. So we shall have negative 1 out of 25 minus 32i out of 25. And simply, the two answers are the same. It is based on the one you want to present. So this is the solution to number 11A of section B, and this is Vision Plus. Thank you. Number 11B for the Giant Mock Examination Mathematics 2024 says, if z equals to 1 plus root of 3i, determine its Roman 1, the length, Roman 2, argument, arc z, and Roman 3, express z in polar form and represent it on an argand diagram. So this is the continuation of the complex number. We did part A in the previous video, and this is part B. So part B, Roman 1 says that we need to find the length. The length, which is the magnitude. So the length of a complex number can also be called the magnitude or the size or the modulus. We have explained all those terms in our list of videos on complex numbers. You can check out that. Now, how do we get the length of a complex number? The length, denoted by z with 2 bars on both sides, is given by, this is the formula. The formula is the square root of x squared plus y squared. Remember, we said any complex number z is in the form of x plus iy. So for us to get the magnitude or the length, we take the real number x and the real number y of the imaginary part. Y is a real number, but it is of the imaginary part. That is what we do. Therefore, if you look at the given complex number, we were given the complex number z as 1 plus root of 3i. So when we compare the general form of a complex number to the given equation or to the given complex number, then we shall deduce that therefore our x corresponds to 1. X is the real part of the complex number, and then y is the real number trapped in the imaginary part, that is root of 3. Remember, in our videos we say that both x and y are real numbers, just that there is a part of a complex number which is imaginary that is attached to y. This form is what we call the Cartesian form or the rectangular form of a complex number. You'll find that in our videos. And therefore, when we substitute here now, we shall say therefore our magnitude z becomes root of, what is our x? Our x is 1, so root of 1 squared plus, what is our y? Our y is root of 3, but the formula says squared. What is 1 squared? If we square 1, we get 1. Press the calculator, plus, what is root of 3 squared? Root of 3 squared is simply 3. Root of 3 squared is simply 3. and then when we simplify that, we shall get root of 4 on adding those two terms, 1 plus 3, it gives us the root of 4. And then when you press the calculator, root of 4 is 2. Ideally, root of 4 is supposed to give us plus or minus 2, but we are looking at the magnitude or the length. Length is a distance, and remember, we do not have negative distances. So we say the length of the complex number is the absolute value, the modulus, or the magnitude. So this is the answer. So the length of the complex number given in this number is 2. How about the argument? In Roman 2, let us do the argument. In Roman 2, which I said, find the argument. What do you remember about the argument? At this time, you must know that the argument of a complex number is the angle. So whenever you hear about argument, think about angles. So argument of a complex number is the angle that the complex number makes with the positive x-axis. That is the definition. But remember, in complex numbers, we represent them on the Argand diagram. The Argand diagram has real axis and imaginary axis. So to modify the definition, we say argument is the angle that the complex number makes with the real axis, with the real positive axis. Therefore, our complex number z was given as 1 plus root of 3i. It was like this. So for us to get the angle in a better way, it is good for us to sketch the Argand diagram. And the Argand diagram is similar to the Cartesian plane, where I'm using my free hand, so use a ruler, where we have the two axes. In the Argand diagram, the horizontal axis is what we call the real axis. But in the Cartesian plane, this is the x-axis. In the Argand diagram, this is the imaginary axis. But in the Cartesian plane, that is the y-axis. At the center, we have origin O. So this is what we call a complex plane. It is not a Cartesian plane. If here is x-axis on the horizontal and the vertical is the y-axis, we call that the Cartesian plane. But the moment we change the axis in this manner, it becomes a complex plane. Remember, this is the real axis, so the real part of the complex number must always fall on the real axis. Like 1. 1 is positive, so it must fall somewhere here. This is my 1. I can mark here also corresponding 1. We just estimate distances reasonably. So if this is 1, this is the corresponding negative 1. And then on the imaginary axis, I have root of 3. Don't plot it as root of 3i, no. You just take the value. The I is already on the axis. So you just locate it anywhere. So this is my root of 3 because it is positive on the imaginary axis. I can also mark the corresponding negative root of 3 here. You can mark anywhere, there is no problem. Now, we had positive 1, which is here, positive root 3, which is here. Where do they meet? Their point of intersection on estimate is somewhere here. This is where they are meeting. Make it face this and make it face that. But use a ruler just to guide you. So you now draw a complex number from the origin up to that point of intersection. Use a ruler. That is where they are going to meet because this one dots like this. And then this one comes vertically down. So a complex number is from the origin up to that point of intersection, and then you put an arrow on it, arrow like that, because it is a vector quantity. The arrow shows the direction of the complex number. What is the argument? Now the argument is this angle here. This angle is what we call the argument. So you can call it angle theta. The choice is yours. I've called it angle theta. Now we just need to find this angle theta. And if you look at this, I'm seeing a right angle triangle here from the hypotenuse formed by the complex number. Then we have the opposite to the angle and the adjacent. So the distance from down here up to up here is the same as the distance from origin up to root 3. So this side is root of 3. Then from here up to here is 1. So this is also 1. Now we just need to find that angle. We can apply any trig ratio from sine, cosine, and tan from SOHCAHTOA. But here we have the opposite and the adjacent. So we just say tan of theta equals to opposite is root of 13 out of the adjacent 1. Therefore our theta becomes the tan inverse of root of 13. And then you press your calculator. Keep your calculator in degree mode. Simply reset your calculator, in other words. So tan inverse of root 3, I'm getting 60 degrees. I'm getting here 60 degrees. That is, this is the tan inverse. And therefore, this is the argument. So here we now say, therefore, the argument of the complex number z is 60 degrees. Simply, this is the angle that the given complex number makes with the positive real axis, which is the horizontal axis in this case. So this is the solution to Roman 1 and Roman 2. In the next video, we shall express the given complex number in the polar form, and then this part that says represented on an Argand diagram is actually what we have done here already. This is the Argand diagram, but I will do it again in Roman 3 because it was specifically asked. But here it was not asked, but it is always good for you to sketch the Argand diagram and then you find the angle theta. That is a formula which normally works, but I do not encourage it because it does not give you the angle relative to the real axis, but it gives it nearest. It gives it to the nearest real axis, but not positive. So I avoid that. Otherwise, that is the solution to part 1 and 2. And as a reminder, this is Vision Plus. This is a continuation from number 11b, Roman 3. Remember very well that part B, we were given a complex number z as 1 plus root of 3i. And we did Roman 1 and 2. Now Roman 3 says, express the complex number z in the polar form and represent it on an Argand diagram. So the first thing that I'm going to do here is to express it in the polar form, and then I represent it on the Argand diagram. Remember, polar form is separate from the Argand diagram. They are different. Now, when we're expressing it in the polar form, in some cases we call it the modulus argument form. There is a formula for the polar form or the modulus argument form, and the formula is that z equals to r into cos of theta plus I sine of theta. This is the polar form or the modulus argument form. Now, what is theta? We have already got theta in the previous numbers, and since it is the same question, we can use values from other sections to answer questions of other sections. So in Roman 1, we got our magnitude of the complex number as 2. And in this case, our R is the same as the magnitude of the complex number. Therefore, our R is also 2, because R is the modulus or the length of the complex number. In Roman 2, we got our theta as 60 degrees. So we shall use the same theta here as 60 degrees. So you can see that the polar form is actually easy, because what you need to do is to find R, which we did in Roman 1, to find theta, which we also did in Roman 2. So we don't need to find them again since it is the same number. So we simply substitute. Therefore, here we shall have our complex number in the polar form Z becomes R. What is R? Our R is the modulus 2 into cosine of theta. What is theta? Theta is 60 degrees plus I sine of theta. The same theta is 60 degrees. And you leave it like this. This is the polar form. When you expand, or when you press the calculator and you get the cosine of 60 and sine of 60, what you are simply doing is you are taking it back to the Cartesian form in which it was given. So this is the modulus argument form. That's why they call it. This is called modulus simply because there is a length, then there is argument, which means there is an angle form. So that is the modulus argument form. So this is the answer for the modulus argument form. We were told to represent it on the Argand diagram, which I did in the previous video, but it was not asked, just that it assists us in finding the argument. So now from here, our complex number Z is given as 1 plus root of 3i. Now the Argand diagram of this would be, first of all, you draw the complex plane of the vertical axis and you have the horizontal axis. The vertical axis is what we call the imaginary axis when you are looking at the complex plane. And then the horizontal axis is the real axis in the complex plane. This one is called a complex plane. But if we represent a complex number on it, then it becomes the Argand diagram. So this is our origin O. The real part of this complex number is 1. So 1 must lie on the real axis. Mark anywhere 1. Then you mark the corresponding value, -1. Approximately the same distance from the origin. And then our imaginary part has root of 3. So you mark anywhere here, positive root of 3 in the question. Then you mark the corresponding negative, which is negative root of 3. When you come back to our question, we have positive 1, which is here. We have positive root 3, which is up here. Then you simply find where they meet. They are intersecting somewhere here. You do not need to be very accurate, and even you don't need a graph paper. This is just rough estimate. Then you use a ruler to a line from the origin up to where the complex number is, up to where they meet. Now this line is actually the complex number. You can put an arrow on it anywhere, but mostly they put it on top, showing the direction, but you can put it anywhere. So that is the complex number Z. this is the complex number z. You can mark it there. That is the complex number z. What was our argument here? Our argument was 60 degrees. So this is the argon diagram that was required in Roman 3, and this is the solution to the whole of number 11b and the end of question 11. So as a reminder, this is Vision Plus, and we encourage you to share these resources with your brothers and sisters, with your classmates and friends, such that your learning is enhanced. In case you have questions or concerns, leave them in the comment section, and our team of experts shall respond to you accordingly. Thank you. Number 12a says, find the equation of the circle whose center is -2 and 3 and has radius 5 units. As you can see, this is from equation of a circle, and we have a full video list on this. So find time and revise. In this question, we are given the center -2 and 3, and we are given radius of this circle as 5 units. I'm going to solve this using two methods. Method 1, which is the factorized form. Remember, there are two forms of expressing the equation of a circle. One is the factorized form, and the other one is the expanded form. So for method 1, I will use the factorized form. The factorized form of the equation of a circle is given by x minus a squared plus y minus b squared equals to r squared, where a and b are the coordinates of the center. So we have a and b, which are the coordinates of the center, and we have r as the radius. So simply what we need to do is to substitute for a, b, and r, and then we get our equation in the factorized form. And therefore here we shall have x minus a. A is -2, and then b is 3. So we shall have x minus a. What is a? A is -2. So we shall say x minus -2 squared plus y minus b. What is b? B is 3 squared equals to r. What is r? R is 5, but the formula says the square of r. And then we simplify this expression. Here we have x minus -2, and that becomes positive. Negative times a negative, we get positive. So we shall have x plus 2 squared plus y minus 3 squared equals to, press the calculator, 5 squared gives us 25. So this is the equation of this circle in the factorized form. Remember, the question was not specific, so someone could choose this method 1 or someone could use method 2. But for purposes of understanding and revision, let me also do method 2. So in method 2, we shall use the expanded form of the equation of a circle. Expanded form. And the expanded form is of the formula that x squared plus y squared minus 2ax minus 2by plus c equals to 0. This is the expanded form. And in this case, a and b are still the coordinates of the center. So a and b are still the coordinates of the center. And here our c has an expression, and in this case c that you see in the formula here equals to a squared plus b squared minus r squared. That is simply the sum of constants. What do we need to do here? Remember, we have our center as -2 and 3, and then we have our radius. It was given as 5 units. This is the center, this is the radius that was given. So since we have the center, it means we have a and b. What we need to find now is c. How do we find c? We use this formula to find c. So our c, which is the sum of all constants, becomes a. Our a is -2, but squared plus b. Our b is 3, squared minus r. R is 5, also squared. Then you press your calculator. This here gives us here 4 plus 9 minus 25. And here I'm getting -12. Here I'm getting -12. So our c is a -12. So after getting c, then we simply substitute there. Remember, we don't substitute for x squared and even for y squared, because x and y are points on the circumference of the circle. Those are the locus. Those are the point loci that we have on the circle. So we don't substitute for them. Minus 2. What is a? Our a is -2. Attach x minus 2. What is b? b is 3. Attach y plus c. What is our c? Was -12. Equals to 0. Remember, when you are substituting for a and b, maintain their signs. Also, substituting for c, maintain its sign. Then from here we shall have x squared plus y squared. -2 times a -2, we shall get positive for x, minus 2 times 3, 6y minus 12 equals to 0. So this is the equation of this circle in the expanded form. The question was not specific, so either way you get the same answer. Even if we had expanded this instead, if we had squared this, then we rearrange, it would give us the expanded form, simply because the expanded form is obtained from the expansion of the factorized form. So the two forms are interconvertible. Therefore, that is the solution to number 12A of the Giant Examination Board. Number 12B says the equation of a circle is given by x squared plus y squared plus 6x minus 2y minus 6 equals to 0. This is the given equation of a circle in the expanded form. Roman 1 says express the above equation in the form x minus a squared plus y minus b squared equals to r squared. The given equation is in the expanded form, but they want us to express that same equation in the factorized form. This is the factorized form that they want, and they have given us the expanded form of that same equation of a circle. So simply, what we need to find is the coordinates of the center and the radius. So without wasting time, the solution to this is, if you look at that given equation, let me copy it here to guide us. We're given x squared plus y squared plus 6x minus 2y minus 6 equals to 0. This is the expanded form. But the general formula for the expanded form is x squared plus y squared minus 2ax minus 2by plus c equals to 0. There is another one. There is another format of expressing the general expanded form of the equation of a circle. You need to choose one and familiarize yourself with it. But the simplest is what I've written here. So this is the general form of the expanded equation of a circle. So from here, we need to find the coordinates of the center, that is A and B. So we need to find the coordinates of the center A and B. This is the center. And also we need to find R, which is the radius of the circle, from the expanded form. After getting the coordinates of the center A and B and the radius R, then we simply substitute them in the factorized form and we express it in that format. So how do we get the coordinates of the center and R? From here, let us compare. We have x squared here, it corresponds to x squared, correct. We have y squared, corresponds to y squared, that is a fact. But we don't have a variable that we need there. So we just confirm that they are the same, because always the coefficient of x squared and y squared are always the same. Like in this case, the coefficient is 1, 1. So they must always be the same. And in the general form, the coefficients are 1, 1. So if they are given the same but not 1, then you make their coefficients 1. There is a playlist that I'm going to share the link in the description box, and please find time and learn from there. So that is enough there. Now, if you look here, we have 6x, and then here we have negative 2ax. So on comparing the terms, we can see clearly that 6x from up here, it is positive, yes, corresponds to negative 2ax. So 6x equals to negative 2ax. Remember, we are looking for a. So x and x will cancel, right? If we divide both sides by x. I may not show that. X and x are going to cancel out. So we shall have 6 equals to negative 2a, right? Then from here we divide both sides by negative 2, both sides by negative 2, simply to get a. 6 divided by negative 2, we get negative 3 equals to a. So we have one of the coordinates of the center A. How do we get the next coordinate? Negative 2y corresponds to negative 2by. So also negative 2y is the same as negative 2by. The y and y will cancel if we divide both sides by y. Therefore, we shall be left with negative 2 equals to negative 2b. Then we divide both sides by negative 2. Negative 2 divided by negative 2, it gives us positive 1. So 1 will be equal to b. So the next coordinate of the center, b, is 1. There is a shortcut. Like for example, if you want to get a here, then you get 6, divide by 2, and you change the sign. It is positive here, so it will become negative. 6 divided by 2, 3. If you look at negative 2 here, it is negative. It is a negative 2. So we make the answer positive. 2 divided by 2, it gives us 1. That is a quick guide. You do not necessarily have to do this, but I've done it to show you the right way. Now from here, we can conclude that our center has coordinates A and B, that is negative 3 and 1. These are the coordinates of the center of this circle. Now from here, we are left now with the radius. We have got the coordinates of the center. How do we get the radius? It's still on comparing here. Negative 6 corresponds to C, or to positive C. So negative 6 corresponds to C. So also, still from the concept of comparing terms, we have seen that negative 6 corresponds to C, or C is a negative 6. But remember, we say that C is a sum of constants, and we say that C equals to A squared plus B squared minus R squared. There are many formats of expressing this. You'll find in some books R is the subject of the formula. It changes nothing in the final output. The difference is just in the expression, but after computing, you get the same values of R. So this is C, which is the sum of constants, A squared plus B squared minus R squared. Now we have our C is a negative 6, substitute for C. And we have our center A and B, so we can substitute and we get our R. So from here, our C is negative 6 equals to, our A is negative 3, but the expression says squared, plus our B is 1, expression says squared, minus R squared. We are looking for the radius now. So on simplifying this, I will have negative 6 equals to negative 3 squared is positive 9 plus 1 minus R squared. Therefore, here I will have negative 6 equals to 10, right, minus R squared. So let me take R squared the other side to become positive. So I'll have positive R squared equals to, I will have here 10 plus 6. If I bring 6 this side, becomes positive. So our R squared equals to 16 in this case. So our R squared equals to 16. Then we take the square root on both sides. Therefore, our R is radius. Radius is a distance. Distances are positive quantities. You cannot have a negative distance or a negative length. Displacement can be negative because it is measured relative to the initial position. But for any distance, it is positive. So root of 16 is supposed to be plus or minus 4. But we shall take plus 4 units because our radius is a distance or length. So now we have got the radius of our circle and we have the coordinates of the center. So we are supposed to now express it in the stated form, which is the factorized form. Substitute for A, B, and R. So now in that case, to express it in the stated format, we shall say the stated format should be x minus A squared plus y minus B squared equals to R squared. And our center was negative 3 and 1. So our A was negative 3, our B was 1, and our R was 4. Simply substitute. So we shall have x minus negative 3 squared plus y minus 1 squared equals to 4, but squared in the formula. Therefore, we shall have x plus 3 the two signs will change to positive. Squared plus y minus 1 squared equals to, what is r squared? That is 4 squared. That gives us 16. So we have expressed it in the stated form, that is in the factorized form. So this is the solution. Please do not leave the squares here. X plus 3, square both of them in one bracket, and the same applies to y minus 1 in one bracket square equals to, then you get the value of r, square it, and it gives you 16. So this is the solution to number 12b, Roman 1. If you look at Roman 2, it says determine the center and the radius of the circle. We have done that already, right? After showing all these calculations, do not repeat it in Roman 2. Why? It is the same number. So just conclude that in Roman 2, the center is, it is here, negative 3, 1, and the radius is 4 units. So in Roman 2, we shall just go ahead and say, our center is negative 3 and 1, and then our radius r is 4 units. You do not need to do them again. Since it is the same number, it will just be a repetition. And as long as you have shown your calculations in Roman 1, you get the marks. Yes. So that was the solution to number 12b, Roman 1 and Roman 2. And as a reminder, if the materials that we are giving you on this platform are of value to you, then we encourage you to share them with your friends, your classmates. We are now going to number 12b, Roman 3, which is the last part of number 12. We were given this equation of a circle in question 12a, and we are still continuing with the same number. So this number tells us to find the length of the tangent that is drawn to the above circle from a point 1 and 2. For us to visualize this better, we sketch a small circle in this manner. It should look like a circle. And by definition, a tangent is a straight line that touches the circle at only one point. Therefore, you draw a straight line touching the circle at any one point. So I'll draw it here down that my tangent is passing like this, touches the circle at that one point and continues. It should be a straight line. So this is the point of tangency. It should touch at only one point. So this is the point of tangency, the point where the tangent meets the circle. Or in other cases, you find a tangent to a curve. And here they have said that the tangent is drawn from a point 1 and 2. So there is a point somewhere here, that is point 1 and 2. These are the coordinates of the point from which the tangent is drawn to the circle. You can draw this tangent in any manner. You can put it up here. It can be vertical or oblique, but the main idea is that it should touch the circle at one point. So this is the tangent, and this is the point where it is touching the circle. Let me call this point A. This is the point of tangency, and the coordinates of the point of tangency are not given. And we also got our center. Our coordinates of the center were -3 and 1, if you remember. These are the coordinates of the center, which we got from the given equation of a circle. Now, from here, what are they looking for? They are looking for the length of the tangent from point 1 and 2 up to point A. So let me call this point 1 and 2 point B. So this distance is our tangent from A to B. This is the length of the tangent, rather. That is the distance that we are looking for. So how can we get it? That is the question. Remember also, in the previous video, we got our radius r as 4 units. So we don't need to calculate it again. So the distance from the center to any point on the circumference is 4 units. So I can put it vertically like this. This is my radius, 4 units. So this distance is 4 units. Now I'm looking for the distance AB. So let me call the center C. I'm looking for the distance AB. Now from here you can see that we have the distance AC, but we don't have the distance CB and the distance AB. So this distance CB is not given, but we can find it, use a ruler. This is the distance CB. So what we shall do is, we shall find the distance CB here. Let me call it X. And then we use that distance CB to find the distance AB using Pythagoras theorem. I've said a lot of words. Let us begin to write. Now, point C and point B, we have 2 points. That is point C. And then we have point B, which is 1 and 2. How do you find a distance between 2 points? That is simply the length of the line CB. Therefore, the distance or the length CB is given by the formula square root of x2 minus x1 squared plus y2 minus y1 squared. Then you come and mark your points. If this is x1, this must be y1. If this is x2, this must be y2. Or you can alternate. You can say this is x2, y2, and then this is x1, y1. But a given coordinate should have 1, 1 or 2, 2. Therefore, we substitute here to find the length. So now from here we shall say equals to, what is our x1? What is our x2? Our x2 is 1 minus x1 is a -3 squared plus y2 is 2 minus y1 is 1 squared. And then from here you press the calculator. 1 minus -3 is 4. 4 squared is 16. So here we shall have 16 plus 2 minus 1 is 1. And 1 squared is still 1. So from here we shall have square root of 17, right? Units. Therefore, our distance that we had called x is root of 17 units. So the length CB here is root of 17 units. Right? So let me redraw this right angle triangle and I put the corresponding sides. So our right angle triangle will look like this. Use a ruler. This is the vertical line. This was our point A. This was our point B. Our point C is up here. But remember, this was the radius 4 units. And this is where our right angle is. We have got the length CB, as root of 17 units. So now we know this side and we know this side, but we don't know the length AB, which is the length of the tangent. But if we apply Pythagoras theorem, remember Pythagoras theorem says the sum of the squares of two shorter sides equals to the square of the longer side. So in other words, the two shorter sides are AB squared and then plus AC squared equals to CB squared. AB squared plus AC squared equals to CB squared. Most people have mastered that it is always equals to AC squared. Depends on how you have marked the points. But it must always equate to the longer side, to the square of the longer side. In this case, we have CB squared. So it is not a must that it is always equals to AC squared. Depends on how the points are arranged. Now from here, we are looking for the length AB. So I'm going to keep it in our formula here. Our AB squared plus what is AC? AC is 4 units. But the formula says squared equals to CB. CB is the longer side, which is root of 17. So root of 17, but we are squaring it by Pythagorean theorem. And now from here, we shall have here our AB squared will be equal to what is root of 17 squared? It gives us 17 minus what is 4 squared? It gives us 16. Therefore, our AB squared will be equal to 1. If we take the square root on both sides, here square root, also here we take the square root, then we shall find that our length AB equals to 1 unit, because the square root of 1 is plus or minus 1, but this is the length, so we take a positive value of the square root. So that is the length of AB. I remember what was our AB. Our AB was the length of the tangent. Therefore, to conclude, the length of the tangent drawn from this given point 1 and 2 to the above circle is 1 unit. This is the answer. We have taken a lot of time explaining this, and I thought that would help you a lot, and for you to understand the whole of equation of a circle, we have a dedicated playlist that can help you to understand this concept better. This is the end of number 12, and we are still continuing with this giant mock examination. A quick reminder, this is Vision Plus. Number 13A, using first principles, find dy dx of the function f of x equals to 3x squared. This is a number from differentiation, and we need to find the derivative of this function here, f of x equals to 3x squared, using strictly first principles. So the solution is, since we are given the function f of x as 3x squared, and we need to use the method of first principles, the formula that we apply when we use first principles is the derivative dy dx of any function, dy dx is equal to it is given by limit limit as h tends to 0 for the function f of x plus h minus the function f of x, all of them, all over h. This is the formula that we apply when we are using first principles. There is also another format of using small changes. It also works, but I do not encourage it simply because it confuses students. And this method is direct forward, and they are the same. Now from here, we simply need to find the function f of x plus h, and then we are given the function f of x, and then we substitute for them in this formula. So for us to find f of x plus h, what we do is we say we are given the function f of x as 3x squared. And then how do we get f of x plus h? F of x plus h. From here, simply what we do is wherever we find x in this given function, we put x plus h instead of x. So we simply say our x now is x plus h. So where you see x here, you put in x plus h. Like in this case here, we shall have 3, but where there is x here, we substitute for it as x plus h. This is x alone, but then we square it. So it will look like that. And then we simply expand. On expanding here, I'm going to keep 3, and then I expand. What is x plus h squared? That is the same as, I believe at this point you know expansion, and in case you don't, visit our playlist of Senior 3 Basic Mathematics. The expansion of this, without wasting time, becomes x squared plus 2xh and then plus h squared. That is the expansion of that. And then we multiply by 3. Multiply all the terms now by 3. That gives us 3x squared plus 6xh plus 3h squared. We are multiplying by 3 because there was a coefficient of x squared given us 3. So we are expanding everything. So this is the expansion. And therefore, this is the function f of x plus h. Now we have the function f of x plus h that we needed to substitute here. And the f of x here is the given function. And now from there, we simply substitute for them in that function. So we shall now say, therefore, our dy dx equals to limit as h tends to 0 for the function. What is f of x plus h? It is here. It is 3x squared plus 6xh plus 3h squared. That is f of x plus h. But the formula says that we subtract away f of x. What is f of x? F of x is 3x squared. F of x is a single term. It is one term. But if it was more than one term, then we put it inside a bracket. But remember, all this is over h. Divide all the terms by h. And then from here we further simplify. So this equals to limit as h tends to 0. I will explain for you how this part of the limit will disappear. Into we simplify this. I'm saying here 3x squared here and 3x squared here are going to subtract and give us 0. So they cancel out. I don't encourage you to cross your work like this in exam, but I've done it already just for now. So those will cancel, and then we shall be left with 6xh plus 3h squared over h. And then from here we divide all the terms by h. So we shall have limit as h tends to 0 for remember we distribute the denominator, so let me show that. We shall have 6xh out of h plus 3h squared also out of h, right? And then we simplify that. So we shall have limit as h tends to 0 for this h and this h are going to cancel. H and h will cancel, so here we shall be left with 6x plus 1h will cancel here, so we shall have 3h. Now at this point we are saying limit as h tends to 0, so as h approaches 0, so as h tends to 0 or as h approaches 0, then we come and substitute for the value of h in this expression. Therefore our dy dx equals to, now when you are tending h to 0 or as h approaches 0, you don't show the part of the limit. Therefore here we shall just have 6x plus 3, but what is h? H approaches 0, so we substitute for it as 0 as it approaches 0. And then from there we simplify. Therefore we shall have 6x, 3 times 0 is 0, and finally our derivative becomes 6x. So this is the derivative that they wanted, and that is the dy dx. So that is how we use first principles. We have very many examples that we have done in differentiation from the beginning up to the application. So you can find time and visit our list of videos on the same channel. Thank you. And then 13b, find the equation of the tangent and the normal to the curve given by f of x equals to 5x cubed minus 7x squared plus 3x plus 1 at the point 1 and 3. So we are given this equation, and that we should find the equation of the tangent and the equation of the normal to this curve at a point 1 and 3. So what do we do? Remember we said for us to get the equation of the tangent and the equation of the normal, we need to get the derivative of the curve or the gradient function of the curve. So we differentiate the given equation of the curve such that we find the gradient function of the curve. It will help us. So since we are given function f of x, we can say the derivative f prime of x, this is the derivative or the gradient function of this curve, equals to, then we differentiate this using the law of powers and coefficients. When we lower 3, we shall have 5 times 3, right, x. Then we subtract 1 from the whole power, so 3 minus 1 gives us 2. Then we have minus 7 times, we drop the power, times 2, x. We subtract 1, 2 minus 1 is 1, so this is the power 1. And then plus, the same. We shall have 3 times 1. X here, x is to power 1 here, but if we subtract 1, this is to power 0. And then plus, if we differentiate a constant, we get 0, simply because derivative is the rate. It gives us basically the rate of change. It gives us how fast the function changes when the variable changes. But here now the variable is x, and the constant 1 is independent of x. So it is not affected by change in x. That is basically what we mean when we say differentiating a constant gives 0. And then here we simplify. We shall get 15x squared here minus 14x plus 3, because x to the power 0 is 1. 1 times 3 is 3. So this is the derivative of that given function. A reminder, this is Vision Plus, and if these materials are important to you, then share them with your friends, share them with students, and share them with your classmates. Let us continue. So this is the gradient function of the curve, and remember, this is the same as dy dx. Okay, it is the same as dy dx, simply because f prime of x is the first derivative dy dx, so we can use them interchangeably. So after getting the derivative, now this is the derivative of the curve. What is the importance of derivative? It gives us the gradient of the curve at a given point. So if this is the gradient function of the curve, we can use the point 1 and 3. This point 1 and 3 is on the curve. And to sketch it quickly, assuming this is our curve, it can be, assuming this is the curve, it can be in any manner. This is not accurate. And then the tangent touches the curve at one point like this, at one point like that. Use a ruler. I'm struggling to draw because I'm using freehand. This is the tangent, and then the normal to the curve is perpendicular to the tangent, something like that. So this is the point, this point where they're all meeting, point 1 and 3, that is the point of tangency. This is a point where the curve, the tangent, and the normal, this is the normal, are meeting. So this point is on the curve. So what I want to do is, I want to find the gradient of the curve at point 1 and 3. So at point 1 and 3, the gradient of the curve, which is dy dx at the point 1 and 3, becomes, where this is x, remember this is y, so where there is x, we put 1, so we shall have 15, x is 1 squared minus 14, x is 1, and then plus 3, and then we press the calculator. So here we shall have 15 minus 14 plus 3. So here I'm getting 4. Okay, so this 4 is the gradient of the curve. At the point 1 and 3. Now, what is the connection between the gradient of the curve and the tangent? That is still here. Now, at the point of tangency 1 and 3, the gradient of the curve is the same as the gradient of the tangent. At the point of tangency 1 and 3, the gradient of the curve is the same as the gradient of the tangent, not the normal. So therefore, we can say the gradient of the tangent is 4 because they are the same with that of the curve at the point of tangency. So now we have the gradient of the tangent 4. Now remember, a tangent is a line, and if we know the tangent, a tangent is a line, and if we know the gradient of a line and one point on that line, then we can find the equation of that line. So this is the gradient of the tangent, and the tangent passes through this point of tangency 1 and 3. So we have the gradient of the line, which is a tangent, and then the point on that line, which is a tangent. So we can find the equation of that tangent using the equation of straight line y equals to mx plus c. So this is our x1, so this is our x, and this is our y. So we substitute. Our y is 3 equals to our m is the gradient. This is the gradient m times x is 1 plus c. Then we make c the subject of the formula. So c is a -1. After getting c, I believe you know how to use the equation of a straight line. So after getting c, then our equation of the tangent becomes y equals to, substitute for m, which is 4, x plus c, but c is a -1, so -1. So this is our equation of the tangent. Equation of the tangent. Now, how do we get the equation of the normal? Remember, the normal is perpendicular to the tangent. Therefore, the normal and the tangent are perpendicular lines. So, the normal is perpendicular to the tangent. And what do you know about perpendicular lines? If the normal has a gradient, call it m1, and then the tangent has a gradient, call it m2, how you name them doesn't matter. Then the law says the product of the gradients of two perpendicular lines is -1. So m1 times m2 is supposed to give us a -1. But we have said m2 is the gradient of the tangent, which is 4, which is here, which is 4. How you name them doesn't matter. You can call this m2 and this m1. It makes no difference. So our m2, which is the gradient of the tangent, was 4. So we can substitute for it here. m1 times m2, which is a -4, which is 4, which is 4, it gives us 4m1 equals to -1. Therefore, m1 equals to -1 out of 4. This is now the gradient of the normal. This is gradient of the normal. Yeah, we are taking time, but these are the steps of the normal. So after getting the gradient of the normal, then we need to find the equation of the normal. Remember, a normal is a straight line. And if we know the gradient of a line, like m1 here, and we know one point on that line, because this normal continues down like this. So we know one point on the line, which is point 1 and 3. That is a common point to the curve, to the tangent and the normal. So we have the gradient m1, and then we have a point on the normal, which is point 1, 3. I think 1, 3, yes. Point 1 and 3. Then we can apply the equation of a straight line, that y equals to mx plus c. If you don't know about the equation of a straight line, visit our list of videos in Senior 1 Mathematics. senior 2 rather. So this is our x, this is y. Then we substitute. Our y is 3 equals to our m is negative 1 out of 4. Our x is 1 plus c. And then you make c the subject of the formula. I'm going to press my calculator and get the value of c. You can follow your normal steps and get c. So c, I'm getting 13 out of 4. So since we have, now let me first write the equation. Since we have c and m, then we can write our equation. So the equation becomes y equals to m. Our m is the gradient negative 1 out of 4, x plus c. Our c is 13 out of 4. And therefore, this is our equation of the normal to that curve. Equation of the normal. So we have come to the end of example 13 of number 13b. It has taken time, but this question was long. I have explained, and in case you want more videos and lessons on the normals and the tangents to curves, then visit our list of videos in differentiation. Otherwise, thank you. Number 14 is a question from statistics, and it reads, the table below shows the marks scored by 65 senior 3 students of Crested Secondary School during a mathematics contest marked out of 100. The table has two columns. The first column is for the score interval. The second column is for the number of students. The first column, we are given the limits. These are the limits. The score interval forms the limits. The column for the number of students forms the frequency. We shall analyze that. Question 1 says, using an assumed mean of 64.5, find the mean score. Part B is, we need to calculate the standard deviation. So, we are going to organize the given data in form of a table for us to easily manipulate and find the requested items in the question. So that table of analysis is what we call the frequency distribution table. You should be familiar with that, and in case you don't have enough knowledge, then visit our list of videos on this same channel, Vision Plus, for a full coverage of statistics. So we are going to organize our data in what we call frequency distribution table, or simply the frequency table, frequency distribution table. In the frequency distribution table, you can see here clearly that I have already stated the limits of the score interval. 40 in this case is the lower limit, 49 is the upper limit of this interval. For the second interval, 50 is the lower limit, 59 is the upper limit, and continues. So I wrote this to save our time, but let us go into completing the full table. I'm using my free hand to draw the table, but you can use a ruler. So we are given the number of students, and that is what we call the frequency. Frequency is just the number of times something appears. So it is the number of times a number or a given interval appears. It is the number of occurrences. So under frequency, which is the number of students, in the interval 40 to 49, we have 10 students. You write it there. In the second interval, 50 to 59, we have 20 students. In the third interval, we have 15 students. Here we have 15 students. 70 to 79, we have 5 students. 80 to 89, we have 10 students. And finally, 90 to 99, I did not copy that well. Should have been here, 90 to 99. We have 5 students. When we get the total frequency, it should give us the stated number of students, which was 65. Simply add them and we get the summation of frequency. So we have filled the second column of the frequency. Here we can get our summation of frequency. So from here we can get the summation of frequency here, which we write like this: summation of frequency. Then we add all those numbers: 10 plus 20, 30, plus 15, 45, plus 5, 50, plus 15, 65. It corresponds to the one stated in the question. So our frequency is 65 as it was stated. Now, we need to manipulate this table in a way that gives us what the question is. Since we are looking for the mean score using assumed mean, or it is also called the working mean or the working zero, we need to get we need to get the midpoint of the score, and the midpoint of the score is denoted by x. Our x here is the midpoint of our score. How do we get the midpoint? For the first interval, we say 40 plus 49 divided by 2. That's how we get our midpoint. We shall say 40 plus 49 out of 2. We do not need to show this one anywhere, but you simply press your calculator. So we add 40 plus 49, it gives us 89 divided by 2. I'm getting 44.5. So the midpoint for the first interval is 44.5. You write it in that manner. And then you go to the second interval, 50 plus 59 divided by 2. That is the midpoint, like we are getting a number midway between 50 and 59. And that gives us 54.5. And it continues for the rest of the numbers. 60 plus 69, we get the answer and divide by 2. That gives us the midpoint between these two numbers, and that will give us 64.5. I'm not going to explain the rest now. And then the next one, it will give us 74.5, 84.5, and then 94.5. After computing the first 3 values, you can see the trend that you are working with. So that is our midpoint. Why are we getting the midpoint? Because the midpoint is important in that it assists us in finding the deviation. And now from here, After getting the midpoint, then we get the deviation. How do we get the deviation? Clean this. We get the deviation by the formula that deviation is given by the midpoint minus the assumed mean. Our assumed mean, or the working mean, was given as 64.5. So we write it somewhere here on top. That our assumed mean, let me complete my table on top here. Our assumed mean A, let me write it here. Our assumed mean A is 64.5. So we are going to compute all this. We find the deviation by getting the midpoint, which is 44.5, minus assumed mean, which is 64.5. So we shall have 44.5 minus 64.5. That is negative 20. It is okay to get the negative number, don't worry. I have explained that myself in the detailed manner, and we have a list of videos. Yeah, this video will take time. I just encourage you to be patient, and we'll go through it step by step. And then continuing, for the second interval, the deviation becomes, our x is the midpoint. So here we shall have 54 minus 54.5 minus 64.5. That gives us negative 10. And then 64.5 minus 64.50. 74.5 minus 64.5, we get 10. 84.5 minus 64.5, we get 20. 94.5 minus 64.5, we get 30. We get 30. So we have got our deviation, which is the midpoint minus the assumed mean. I'm coming up with this table slowly. That's why. Okay. After getting the deviation, then we need to get FD. Why are we getting FD? FD is the frequency times the deviation. We are getting FD because it is part of the formula of assumed mean. We know that when we are finding mean using the assumed mean, we say our mean x bar equals to the assumed mean plus the summation of FD out of the summation of F. This is the formula. So we need to get all these values such that we substitute them in the formula for finding mean using the assumed mean. I will quote this formula again when we reach down there. So how do we get FD? FD is the frequency times the deviation. That means for the first case here, we shall have 10 times negative 20. That gives us negative 200. And then 20 times negative 10, we again get negative 200. 15 times 0, we get 0. 5 times 10, we get 50. 10 times 20, we get 200. And finally, 5 times 30, we get 150. That is our FD, frequency times the deviation. So from here, let me complete my column here. In the formula, we are supposed to get summation of FD. So put here summation of FD. And then we add all these negative 200, negative 200, we add all the values in this column. So on adding, let me press my calculator. On adding, I'm getting 0. Because here we shall have negative 400 and also down here we shall have positive 400. So the summation of FD is 0. And if you look at the question, we also need to find the standard deviation. The formula for standard deviation wants us to find FD squared. So let me include the column here for FD squared. If you know the formulas, then you can easily manipulate the table. But this table is not fixed, it is flexible. In case you have realized you need something, just come and add its column. The arrangement is not fixed, it is flexible. Just that first the score and the frequency are the determinants of the results. So you put them first to guide you. How do you get FD squared? Now, if you look here, we have F, and here we have D, and then again here we have FD. So there are two ways. One is someone can get the values of deviation times the values of FD, because that becomes D times FD, and that gives us FD squared, and we shall have obtained FD squared. Or someone can get F and then times, they get the value of D and they square it. So you say F times negative 20 squared. They give the same results. When someone says it is F times D squared, we still get FD squared. We have a full playlist on that, so you get time and visit. So I'm going to use the D and FD to find FD squared, such that I just say negative 20 times negative 200. I'll get positive 4,000. Press the calculator. I say negative 10 times negative 200, I get positive 2,000. 0 times 0, I get 0. 10 times 50, I get 500. And then 20 times 200, I get 4,000. 30 times 150, I get around 4,500. Press the calculator. So that is our FD squared. FD squared. These are the things that the mean using assumed mean and the standard deviation require. So our summation here now of FD squared, you simply add all these values. So we shall have here 6,000, 6,500, 10,500, and then 11,000, 15,000. I'm getting 15,000 here. I'm getting 15,000. So here we write 15,000. That is the summation of FD squared. So basically, this table has taken us time. I did not want to draw it and then I come here and just explain, but I wanted to give you highlight on how you come up with a table. Your table should include what you need to use. And in case your table is not exhaustive and you have reached the questions, but you have found where you needed to add something, you just come back and add it in this free space. But it is good to plan properly so that your table fits in the given space. So that is our table. So for us now to answer, to find the mean using assumed mean, that is our part A now. Our mean x bar using assumed mean is given by the assumed mean itself plus the summation of FD over the summation of F. And then we substitute. We were given assumed mean as 64.5 plus the summation of FD. This is our FD column, and the summation was 0 here. So plus 0 over summation of F is just the total frequency. That is the total number of students in the class, divide by 65. And then you compute. What is, here we shall have 64.5 plus 0 divided by 65, we get 0. And therefore, when we add here, we shall have 64.5. This is our mean using the assumed mean. So this is the answer for the first part. After drawing this table, the rest of the questions become very easy and straightforward. Most students face challenges drawing the table, but after getting the logic, they easily understand. Calculate the standard deviation. Part B rather, the standard deviation. What do we know about the standard deviation? Standard deviation, it is given by sigma. So standard deviation sigma equals to the square root of what we call variance. New terms are coming in. Please go and watch our videos. We have what we call variance. But how do we get the variance? Now the variance has a formula. That variance equals to summation of fd squared over summation of f minus summation of fd over summation of f, but both of these are squared. This is the formula for getting the variance. Please, this symbol means summation. This one means summation. It is just adding mass numbers. Adding like a collection of numbers. If I say mass numbers, those ones who know chemistry will argue with me because it has a different meaning. So this is how we get the variance. So simply, our standard deviation sigma is the square root of variance, which is given by the whole of this expression. So let me go to the next page. Therefore, get the variance and then I substitute for the value of the variance. So our variance, we have said, it is the summation of fd squared out of summation of f. So you come and look for the summation of fd squared. It is here, 15,000. So we shall have 15,000 divided by the summation of f, which was 65 students, minus, open the bracket. We look for the summation of fd. Summation of fd was 0, as you see here. So 0 out of is still the summation of f, which was 65, but this side says squared. It is not a must for the summation of fd to be 0. It depends on the number and the value of the assumed mean. And now from here, we simplify this. We shall have, I'm dividing this side. $15,000 divided by 65, I'm getting 230.7692. Write 4 decimal places, minus the whole of that side becomes 0. And therefore, our variance is 230.7692. That is just our variance. But remember, our standard deviation sigma equals to the square root of variance. And therefore, here we just substitute for the value of variance. That is 230.7692. And then you press the calculator. Get the root of your answer. I'm getting 15.1901. Yeah. So this is our standard deviation. Therefore, our standard deviation sigma equals to 15.1901, and that is the solution to part B for the standard deviation, and that is the solution for using the assumed mean. So please get time. I have made a full list of videos just for you to understand statistics. When you visit there, you will familiarize yourself with how this table works, and you will master all the formulas that are used, and even you'll go ahead to know the definition of terms like the standard deviation, the variance, the mean, plus other terms like the mode, the median, and even how to plot graphs. It is very, very understandable, and you have the right to complain because of the time we have taken. But I thought it would be very, very significant for you to go through it step by step as we have done. A gentle reminder, this is Vision Plus, and these materials are designed to help you succeed. Share them with your friends, your classmates, and have a good day. Number 15 of the giant examination board reads, using a graph, determine the wanted region formed by the inequalities given below. The inequalities are x is less than or equal to 6, x is more than or equal to 2, y is less than or equal to 4, and x plus 2y is more than or equal to 6. So we are given 4 inequalities, and that we need to draw a graph, and then we show the wanted region that is satisfied by the given inequalities. This is Vision Plus, and we have a detailed video explanation of the topic linear inequality and programming. To continue here, the first inequality is x is less than or equal to 6. And let us do the analysis of each of the given inequalities one by one. So for the inequality x is less than or equal to 6, number one thing that we need to know, this is going to be a straight line. So one fact is, it will be a straight line. And the straight line will be in the form x equals to 6. We simply change the inequality symbol to equal sign just for us to analyze it better. So our x equals to 6. So this is a straight line that cuts, right? It cuts the x-axis at 6. It cuts x-axis at that number 6. And if you look at it here, x is less than or equal to 6. So since x can be equal to 6 or x is less than 6, then our line becomes a solid line. It is a solid line, solid or thick line, or continuous. Actually, this is the main thing. It should be a continuous line. What do you remember? We said if it is less than or equal to, or if it is more than or equal to, this one is a solid line or continuous. it is a continuous line. But if it is less than or it is just more than, this one is a dotted line. Dotted or discontinuous line. We have explained that in our video on this topic. Or discontinuous line. So this is how we get the lines. These are the lines, these are the inequalities, and that is the nature of their lines. So for x is less than or equal to 6, we have said it is a straight line, and x is equal to 6. That means it cuts the x-axis at point 6, and then it is a solid line or continuous line simply because it is less than or equal to in the same inequality. That is the analysis for that. And then the next inequality is x is more than or equal to 2. Yeah, be patient here. We may take time, but it is very important that we have a basic understanding of this part. And for the next inequality, the first fact is that it is a straight line. Actually, all the inequalities that you'll be given will always be straight lines. They will always be straight lines, unless otherwise. But for this level, we deal basically with the straight lines of inequality and linear programming. What is the next thing here? We shall assume that the line is x equals to 2. So the line is cutting the x-axis at 2. I've written here straight lines, but should be straight line specifically for that, yes. And then we have said it cuts the x-axis at what? At position or at point 2. And then look at the inequality. It is more than or equal to. So it falls in our first rule. So there, it is a solid line or it is a continuous line. Continuous line. And here we mean that the line, if we say here continuous, like that is the line. But if we say dotted or discontinuous, then the line is like this. It is dotted line in that manner. So we have done the one for the second inequality. For the third inequality, y is less than or equal to 4. For the third inequality, y is less than or equal to 4. Y is less than or equal to 4. Then we confirm. Yes. So what are the properties of this line? The first property is that it is a straight line. I'm doing this for your review and say that when I explain the graph, you have a basic understanding. And then this is a line y equals to 4. Why? Because here there is y, not x. So the line y equals to 4, it means the line cuts the y-axis now. It cuts the y-axis at point 4. Basically that. And what is the next property? It is less than or equal to. And therefore it is a solid line or it is a continuous line. It is good for you to do separate analysis like this. What is a continuous line? And then finally, the last inequality is x plus 2y is more than or equal to 6. X plus 2y is more than or equal to 6. Let me confirm. Yes. Now for this line, for the lines that we have been doing, you have seen that we were straightforward. The only variable was either x or y. Like here in the first case, our variable here was x. In the second case, it was x. In the third case, towards y. So that's why we're going straight, as we have seen. But the next inequality has x and it also has y. So what do we do? What we do here is we get table of results. Get table of results. And what we do, as I've said, we change the inequality symbol to equal sign just for the analysis. So we shall have here x plus 2y equals to 6. And you can see that this is a straight line, okay? But this line is not vertical and is not horizontal. It is slanted. It has a gradient. Yes, and in this case, you can see our gradient, if we rearrange, would be a -1. It has a negative. It will be a -1/2 anyway. But that is not your analysis, because you know equation of straight line is y equals mx plus c. So if we make here y the subject of the formula, then our y becomes 6 out of 2 minus x out of 2. So our gradient is the coefficient of xm. So our m is a -1/2. But that is not your task. Your work here is to tabulate your results in a table. Just change the inequality to equal sign. And therefore we shall have our x here, our y here. Remember, this is a straight line. And for a straight line, 2 points on the line are enough for you to note other properties of the line. So after coming up with your table in this manner, then you choose, you yourself, you decide for the values of x. Okay? Someone can decide for the values of y. It is fine. It is fine. But since my inequality here started with x, I'm going to assume the values of x. But someone can also assume the values of y. So if x is 0, please choose values. These are the input values of x. Now what are the output values of y? I've chosen x as 0. If x is 0 here, then I will have 0 plus 2y equals to 6. Therefore my y here becomes 3. So here you just write 3. You don't need to waste time here. And then you choose any other value of x. Remember, the values of x that you are choosing are the ones that will give you the right or reasonable value of y. Someone here cannot choose a value of x and say, may I want my x to be 10,000. It is fine, you can use 10,000, but how will you plot it? You will suffer. You need to get a scale that will compress 10,000 to as small as the values like 6 and the rest. So choose reasonable values that you can plot anyway. Any value that you can plot is fine. You get the same answers as any other person who has chosen smaller values. Saving time, I'm going to choose here my x as 2. So that if my x is 2, I will have 2 plus 2y equals to 6. If you make y the subject here, y becomes 2. So if x is 2, y is also 2. So these are the values of x and the values of y. So for us to plot this inequality, we need to plot the following points. So the points that we are going to plot for that number are points 0 and 3 and the point 2 and 2. Those are the points that we are going to plot. That is 1. And again, the other properties are the same. It is a straight line. So this is one fact. Another fact is that it will be a straight line. It will cut the x-axis and the y-axis and the points that we have deduced here. So, and it is a solid line simply because it is more than or equal to. So it is a solid line or continuous line. or continuous line. Choose one and get yourself familiar with it. So this is the overall analysis of the inequalities that we were given in number 15a that we need to represent on a graph. So let us now go to the graph. Now number 15b is asking that we calculate the area of the wanted region. So if you come back to your graph here, our wanted region is here. This is the wanted region, this one in the middle here, and that is the region we said forms a trapezium. So first of all, the area that we need to find is the area of trapezium, because our shape is a trapezium. So, and our trapezium has a formula that area of trapezium is given by a half h into a plus b. That is the formula for getting the area of a trapezium. And if you come back to your graph here, this is our trapezium. From here up to here, how many units are there? Remember, our scale was that from here up to here is 1. So each square has dimensions of 1. The sides are 1. So from here up to here is 1, 2, 3, 4. So up here we have 4. And then vertically on this side we have from here up to here is 1, and again from here up to here is 1. So this side is 2. And then the longer vertical side we have 1, we have 2, 3 and 4, right? 4. 1, 2, 3, 4. This 4 here. This side is 4. And then how about this side? This slanting side. Remember, the slanting side is not important when we are looking at trapezium, so we leave it out, but we would get its distance. Why? Because this is like there's a point here and there's a point here, so you can just find the length of the line between 2 points using the formula for finding the length. So from here I'm going to sketch that trapezium, and what I remember is that it looks like this. Use a ruler for any drawing. Looks like that. And there is also a vertical line in this manner. There's a distance here from here to somewhere here, and then slanting. And we have got this side to be 4 units. This side is also 4 units. This side is 2 units. Yeah, my sketching here is not to scale. All these are units because it is not defined. So those are my dimensions. And remember, in most books you find this part is dotted. That doesn't matter. And if we are to label which one is A, B and which one is H, remember this is our H, this side is supposed to be our H, and then this is our B, and this is our A. But for the length of A and B, it doesn't matter how they are, because it is basically a sum. But our H is that side, because in most books and in many literature it is drawn like this. It is just a matter of flipping that. If we turn this trapezium to stand, if this one becomes our base, if we make it stand on this side, then we shall have that side there. That is where it is standing. And then this height of 4 goes up in this manner, and then this smaller distance of B, move it like that, and then the joins back here and dotted here. So I've just turned it. This was the base, is the one which is A here. I'm putting 4, and then the whole of this side is our H here, which is also 4 units. And then from here up to here is our B, which is 2 units. Yeah, this length is not important, but it is possible to find. So now from here, what is our area? Therefore, our area becomes a half times h. What is h? Our h is 4, right? Our h is 4, and then into our a is also 4 plus b, our b is 2. If we divide this and this, we shall have 2 into 6. 6 times 2, it is 12. So our area is 12 square units. Yeah, because the unit was not identified. Therefore, our area is 12 square units. And that is the answer, basically. For you to understand more on trapezium, then get time, go to our senior 2 class and also go to our senior 3 classes, and then you'll be in position to learn that better. Otherwise, that is the solution to number 15B. And a reminder, this is Vision Plus, giving you these amazing resources. Thank you. And finally, part C for number 15 says, use the above wanted region to find the maximum and the minimum value of 2x plus 3y. So we need to find the minimum and the maximum values of 2x plus 3y. So what we do is, we go back to our graph of the wanted region, which is here. This is our graph. One thing I can tell you is that if you are looking for the minimum or the maximum values, they are always at the corners, okay? They are always at the edges. So there's one corner here, or one edge, or one vertex. There's another one here. There is this one here, and then there is that. So the minimum value or the maximum value is always at the edge of a given shape. It is not outside the shape, but it is at the edge of the shape. That means it is on the boundary. So on this edge here, we have points 2 and 4, right? Because we read like this, you come down 2 and 4. So one of the points that possibly contains the minimum or the maximum value is point 2 and 4. So I have identified one point. I have point 2 and 4. I'm listing points first, and then we come and test for the maximum and the minimum. So there is a point here that I've taken already. There's another point here, which is going to be 2 and 2. So the second point that is possibly the minimum or maximum for a given point, there's another point there. It is 2 and 2. And then again, the third point is in the next corner here. And this corner here, what does it contain? This corner contains 0. No, it contains 6 and 0 because it is on the x-axis. So we have here a point of 6 and 0. So you just come and list another point here. Someone can mark them A, B, and C. You can name the corners and then you name the points with the same, no problem. So that is the third point, 6 and 0. And then the last point is here, which corresponds to 6 and 4. 6 is x, y is 4. That is our last point, 6 and 4. So the last point here is what? 6 and 4. That is our last point. What do we do here now? Remember, these are the values of x. This is y. This is x. This is y. Always the first one is x. The second one is y for any coordinate point. So what we just need to do is we substitute for this point and we get the value. Substitute for the next point up to the end. So for the point 2 and 4, we shall have 2x plus 3y being equal to 2. What is our x? Our x is 2. This one. Plus 3 times our y is 4. So this gives us here 4 plus 12, right? And this is 16. 4 plus 12, I'm getting 16. So this is the value for the first point. And then we also go to the value for the second point. Second point is 2 and 2. So we shall say 2x plus 3y equals to 2 times x is 2 plus 3 times y is 2. This is 4 plus 6. This is 10. That is for the second point. And then now for the third point, I'm going to do it here. Third point is 6 and 0. So we shall have 2x plus 3y equals to 2 times our x is 6 plus 3 times our y is 0. This gives us 12, right? Yes. And then we go now to the last point, which is 6 and 4. This is x and that is y. So we shall have 2x plus 3y being equal to 2. X is 6 plus 3 and y is 12 and y is 4. Sorry. X is 6, y is 4. 2 times 6 is 12. 12 plus 12, we get 24. So the first point is there. So these are the values, right? Those are the values. And what was the question saying? Use the above wanted region to find the maximum and the minimum value of this. So the maximum value, you just come and look at these values, 16, 12, 10, and 24. So the maximum value, as you can see, is what? 24. And the minimum value is the smallest value. Minimum value is the smallest value, which you can see there clearly that it is 10. So this is the solution for the minimum and the maximum value of 2x plus 3y of the question number 15. Yeah, this question has taken us time. I think it is the one that has taken the maximum amount of any time that we have spent in this paper. Otherwise, it was worth it. These resources are brought to you by Vision Plus, and we say thank you for learning with us. Number 16a reads, using the quadratic equation ax squared plus bx plus c equals to 0, where a is not 0, derive the formula x equals to negative b plus or minus square root of b squared minus 4ac all over 2a. We are to derive the quadratic formula from the given quadratic equation. The given quadratic equation is ax squared plus bx plus c equals to 0. And they have said clearly where a is not 0, because if a is 0, then it becomes a linear equation. So how do we solve this? For us to derive this formula, we need a very strong knowledge of completing squares. Which is basically a creation of a perfect square number. When we are deriving the formula, we apply the concept of completing squares. And when you are solving any quadratic equation, the coefficient of x squared must always be 1. But if you look here, the coefficient of x squared is a. So we must make sure that the coefficient of x squared is 1. How do we do that? We simply divide all the terms by a. So we divide this term by a, we divide this term by a, and also this term by a, even 0 divided by a. we divide all the terms by a for us to make the coefficient of x squared 1 in this case. Therefore, we shall now have x squared plus b out of a x plus c out of a equals to 0 divided by a is 0. If you divide 0 to any number, you get 0. So we have rearranged such that the coefficient of x squared is 1. We have simplified that. Now, before I do anything, let me first take away this number. C out of a is a constant, right? This is a constant. So I will take it to the other side of the equation, such that I remain with x squared plus b out of a x equals to, if I carry c out of a, it becomes negative c out of a on this side of the equation. Now, from here, what does completing the square method say? Completing the square method says that we get half of the coefficient of x. It says, the completing square says we get half of the coefficient of x. Get half of coefficient of x. So if we look at this, what is the coefficient of x? Coefficient of x here is b out of a. What is the half of b out of a? Half of b out of a. It means we get a half of the coefficient of x, which is b out of a. This is the same as a half times b out of a, and this is simply b out of 2a. So we have got the half of the coefficient of x. What does completing square also tell us? It says that we square the half, square that half. There's no I here. So the coefficient of the half of the coefficient of x is b out of 2a, and then it says that we square it. So we get b out of 2a and we square it. So this is the square of the half of the coefficient of x. I may not write every word. So we have squared the half of the coefficient of x. And then finally it says that we add the square of the half of coefficient of x on both sides of the equation. So after getting the square of the half of the coefficient of x, which is here, then we simply add it on both sides of the equation. My apologies, I have background noise a bit in the neighborhood. Apologies for that. Yeah, the noise has just come up after me starting the video. So we come back here. Remember, this was our equation. So we are supposed to add the square of the half of coefficient of x on both sides of this equation. So the equation is x squared. The equation is x squared plus b out of a x equals to negative c out of a, right? Yeah. So here what do? We now get this squared half of coefficient of x and we add it here and there. So here we shall have x squared plus bx out of a plus b out of 2a squared. This is the half I've added on this side equals negative c out of a. I also add the same square of the half like that. And then the last rule says simplify. So we are simply going to simplify and then rearrange to meet the standard of the equation. So from here there's not much logic. Now if you look here, we have created a perfect square, which is the goal of completing squares. What is the perfect square here? The perfect square becomes, we shall have x, you simply take this x here, plus, then you come and take b out of 2a squared. Remember, if we expand this, it should be able to give us the whole of this. So we are trying to factorize the whole of this expression. So it gives us x plus b out of 2a, all of them squared. And if we expand this one, it takes us back to this one that you are seeing up here. So we have created a perfect square. X plus b out of 2a squared then equals to, here we have negative c out of a plus, then you square. Since they are both in the bracket, the square applies to the numerator b and the denominator to a. Therefore here it gives us b squared out of 4a squared. If we square 2a, we get 4a squared. And then I'm keeping this side the same, x plus b out of 2a squared equals to, I want to combine these two. So what is the LCM? The LCM is 4a squared because it can be divided by the two numbers. So the LCM of a and 4a squared is 4a squared. What is 4a squared divided by a? We get 4a. 4a times negative c, we get negative 4ac. 4a squared divided by 4a squared is 1. 1 times b squared, we get b squared, so plus b squared. And then from here, we take the square root. We take the square root on this side, and also we take the square root on this side. And after taking the square root, remember this root and these two will cancel. So going to the next page, we shall have x plus b out of 2, b out of 2 to a. Remember the square disappeared, it was taken by the root. So we shall have x plus b out of 2a equals to, and then we take the root of the whole of that number. So equals to, remember when we take the square root of any number, we get plus or minus. And then we can distribute the root since it is a fraction. So this is the same as, I saw negative 4ac plus b squared out of, we had 4a squared, so out of, again root of 4a squared. Yeah, I have distributed the root on the numerator and the denominator. Therefore here we shall have x plus b out of 2a equals to negative plus or minus root of, and then I rearrange because in the formula that we were given it starts with b squared minus 4ac. I have just changed the order, but the sign is for this number. The sign of a number is the sign before it, so I've carried it with a negative, and then b was positive, it is still positive here, all over, right, over, what is the square root of 4? It is 2. What is the square root of a squared? It is a. So the square root of 4a squared is 2a. Okay, the plus or minus is already accounted for in this expression. Now from here, remember we are making x the subject of the formula. So our x here becomes equal to, if I take this one to the other side of the equation, if I take b out of 2a, it becomes negative b out of 2a. Then I continue, I have plus or minus there, root of b squared minus 4ac, and then this is over 2a, right? Use a straight line, please. Over 2a. Yeah, and if you look here, we have a common denominator, right, of 2a. If we have a common denominator of 2a, then the LCM is 2a, right? So the LCM here, or the common denominator, is 2a. And then on the numerator, we just keep all the numbers of the numerator because they have the same denominator. Or 2a divided by 2a, it is 1. 1 time is a negative b, we get negative b. Then we keep the signs, plus or minus, square root of, and then we keep this the way it is because 2a divided by 2a is 1. 1 time is the whole of that, it remains the same. Any number times 1 is that number. Any expression times 1 is that expression. Therefore here we shall have b squared minus 4ac. And therefore this is the formula that we asked to derive. And if we go back to it, it is here, negative b plus or minus root of b squared minus 4ac all of them over 2a. And if you look here, this is the same thing that we have, and therefore that is the solution to number 16a, deriving this quadratic formula from a given quadratic expression, applying the concept of completing squares. Remember, there are about 4 methods of solving quadratic equations. 1 is factorization, 2 is completing squares, 3 is the formula method, 4 is the graphical method. Number 16b, use the above formula to solve the equation 5x squared minus 8x minus 4 equals to 0. The formula that we derived was the quadratic formula x equals to negative b plus or minus root of b squared minus 4ac, all of them over 2a. This is the quadratic formula, or the bulldozer, which we derived in the previous video. And the question says that we need to use this formula to solve this quadratic equation. Remember, quadratic equation is in the form ax squared plus bx plus c equals to 0. And if we compare the general form to the given form, we are given 5x squared minus 8x minus 4 equals to 0. So on comparing here, we see clearly that A corresponds to 5, right? B corresponds to negative 8. The sign before a number is a sign of that number. If it is positive, you keep it without any sign. And then C is a negative 4. So we have A, we have B, and we have C, which are the ones we need to use in the formula. So simply we substitute for them in the formula. Therefore, our x becomes equal to negative b. What is b? B is a negative 8. The negative is of the formula, and then the value of b is also negative 8. So we shall say negative 8. One is for the formula, one is for the value. Someone could put it in the bracket. They are the same. And then plus or minus square root of b squared. What is b? B is a negative 8. But the formula says square b. Then minus 4 of the formula. What is our a? Our a is 5. What is our c? Our c is a negative 4. In that manner. All of them over, use a ruler, over 2a. What is our a? Our a is 5. And then we simplify from here. So from here we shall have negative 8 becomes positive 8. So this one becomes 8. And then plus or minus square root of negative 8 squared gives us positive 64. And then we multiply this. Negative 4 times 5 times negative 4. You press the calculator, but it will become a positive. Positive 80. Yes. Negative 4 times 5, negative 20. Negative 20 times negative 4, positive 80. And then all of them over. Do not forget to divide over that. 2 times 5 is 10. And then we simplify further. Shall have 8 plus or minus root of, what is 80 plus 64? It is 144 over 10. So from here, remember, quadratic equation has two values of x, or it has two roots. So the roots will be either we shall have either, this is still x, either x equals to 8, then you take plus first, plus root of 144 out of 10. And then you simplify. Here even someone would first get the root of 144 here, and then it starts to get the roots. There's no problem, it is all the same. Therefore, here we shall have 8 plus, what is the root of 144? It is 12 out of 10, right? What is 12 plus 8? It is 20. What is 20 divided by 10? It is 2. So here the first value of x is 2. This is the first root. Or for the off part, we shall say x equals to 8, and then we take the minus now. Minus root of 144. And do not forget to divide by 10. And therefore, what is the root of 144? It is 12. So we shall have 8 minus 12 out of 10. What is 8 minus 12? That is negative 4. Negative 4 divide by 10, we get negative 0.4, right? Yes. So these are the values of x. So you conclude therefore x equals to 2 or x equals to negative 0.4. And this makes the solution to number 16b. A gentle reminder, this is Vision Plus, and if the materials are valuable to you, we encourage you to share with your friends, your classmates. Thank you. The last question of this paper. The figure below shows a right pyramid standing on a square base. The edge of the base is 4 centimeters. The slanting edges of the pyramid are 7 centimeters as shown in the figure below. So number 17, we are given a pyramid standing on a square base of dimensions 4 centimeters. And then the slanting edges are each 7 centimeters. And the figure is here. Question A says, calculate the total surface area of the pyramid. So if you look at this pyramid, we have the base A, B, C, D, which is a square base of sides 4 centimeters. And then the slanting surfaces are, we have A, B, and V, and then back to A. That is one of the slanting surfaces or planes. And then there's another one on this side, that is V, B, and C, and back to V. That is the second surface. And then the third surface is behind, that is V, D, C, and back to V. And then the last surface is A, D, and V. So those are the surfaces of this pyramid. So for us to get the total surface area, we simply need to get the areas of each of the surfaces, including the base, and then we sum them. So I'm going to begin with the area of the base area. If we look at the base formed by the corners or the edges A, B, C, D, it has dimensions 4 centimeters. So the base is a square, and the area of the base is the same as the area of the square given by length square or side squared. And therefore here we shall have 4 times 4. And then 4 times 4 gives us 16 centimeters squared. So the area of the base alone is 16 centimeters square. Why? Because the base is a square, and the area of a square is obtained by multiplying the side times side. That is one of the areas constituting the total surface area. Now, if we look here, we have slanting surfaces, and ideally, since the base is a square, the slanting surfaces are identical. Let me say that again. Since the base is square, the slanting surfaces are identical. In other words, since there are 4 slanting surfaces, we simply need to get the area of one of the slanting surfaces, and then it is the same area for the other 3 slanting surfaces. So I'm going to extract only one slanting surface, and then we use it for calculations, keeping in mind that it is identical to the rest of the slanting surfaces. So you can choose any slanting surface that you can easily visualize. What I'm going to choose is the surface that is I'm choosing the surface V, B, C, and back to V. And to sketch that, I'm taking this surface here. This is the surface I'm taking. V to B, and then to C, and back to V. That is one of the surfaces, okay? And let me mark for you all the surfaces. Another slanting surface is A to V to B and then back to A. So there is a slanting surface that I've highlighted the boundaries in blue. And then the other slanting surface is going to be V, and then we go to D behind, and then we come to C and back to V. So there is a slanting surface which is V, D, C and back to V. And now the last slanting surface is V, it goes to A, it goes to D and then back to V. One thing that you must keep in your mind is these slanting surfaces, they share boundaries, okay? They share boundaries. That's why you see I've repeated colors, because they share boundaries. Like on a given line, you may see two colors. So those are the surfaces that we have. So from here, I'm going to take this surface V, B and C. So that surface is like this. It is like that. And then this corner is where I have my B, yes, which is this corner here. And then up I have V for village. And then I have this edge C. So this is where I have C. So if you look clearly, we have B, V and C. Those are the edges of the surface that I'm taking, which I have marked clearly. And then now the distance or the length BC is 4 centimeters. So here I will put 4 centimeters. And then the slanting surface has a length of 7 centimeters. This length VC. This is the length VC, which is 7 centimeters. So this side here is 7 centimeters. So I have extracted one of the surfaces which has formed a triangle, right? It has formed. If we are to classify it, we see that two sides are equal, right? What type of triangle is that when two sides are equal? Let me see that in the comment section. But that doesn't affect our calculation here. So I have extracted that. Now we need to find the area of this triangle. I remember the area of the triangle A. This is a triangle. Let me name it somewhere here. Let me name it here. So the area of a triangle is given by a half times base times height. And what is the base? Base is 4 centimeters, right? But what is the height? We don't have the height, or we don't know the height yet. So we need to find the height. How do we find the height? Remember, the height is the perpendicular from V to meet the line BC. This is our height. It makes a right angle here with the base. That is our height. So how do we find the height? For us to find the height, we need to apply Pythagoras theorem. And it means we have the length BC, which is 4 centimeters. That means if I mark this point here as O, then from B to O, this side will be 2 centimeters. And then this side becomes 2 centimeters, right? So that there is a total of 4 centimeters on BC. So for us to find the height, we use Pythagoras theorem, and we shall extract something of this sort, half of that triangle. Yes, half of this triangle, where this is our height, this was our side 7 centimeters, but now half of 4 centimeters gives us 2 centimeters. So this side is 2 centimeters. Now from here, this is a right angle triangle. This is a right angle triangle, but the whole of this triangle is not a right angle triangle. Okay, so we form a right angle triangle and then we apply Pythagoras theorem. And Pythagoras theorem says if you get the squares of two shorter sides and then you add them, they will equal the square of the longer side. In other words, if I get h squared plus 2 squared, they must give me 7 squared. That is Pythagoras theorem. Pythagoras. And therefore, I will have h squared plus 4 equals to 49, right? Press the calculator and simplify the squares. Therefore, my h squared becomes 49 minus 4, I'm getting 45. And therefore here my height, I take the square root on both sides, okay? And therefore my height here becomes, press the calculator, square root of 45 should be 6 point something. 6.71. 6.71. I'm writing to 2 decimal places for now. So this is our height. Our height is 6.71 centimeters. So after getting the height, then we can find the area of this triangle. Remember, our base was 4 centimeters and our height now is 6.71 centimeters. Someone may think 2 centimeters is the base, but that is not true. 2 centimeters would be the base if the original triangle was in this format that we have extracted, but it was not in that format. It was of this format. So the whole BC is the base. And after getting that, then we say our area of this triangle becomes a half times base 4 times our height, which is 6.71 centimeters. Press the calculator. I'm getting 13 centimeters. 13.42 centimeters squared. Remember, this is area. 4 is in centimeters, 6.71 is in centimeters. Centimeters times centimeters, it gives us centimeters squared. So that is our area. And remember, this area that we are getting here is the area of one of the surfaces, right? It is the area of one of the identical surfaces, one of the identical slanting surfaces. So now that we know one of the areas, but there are 4, what would be the total area for the slanting surfaces? So total area for slanting surfaces it becomes that 13.42, right, times 4, because there are 4 slanting surfaces. Therefore there are 4 slanting surfaces, as I told you before, V, B, C, and the others. So we multiply the surface area of one surface by 4 to give us for all the 4 surfaces, and I'm getting 53.68 centimeters squared. So this is the total area for the slanting surfaces. But remember, the pyramid has a base, the base A, B, C, D, and the area of the base was 16 centimeters squared, right? So the total surface area becomes the area of the slanting surfaces, the sum of the areas of the slanting surfaces, 53.68, plus the area of the base, 16 centimeters squared, and then you add. I'm getting 69.68 centimeters squared. So this is the total surface area of the given figure, which was a pyramid. That is the total surface area of this pyramid that we are given here. So that is the solution. A quick summary: 1. Get the area of the base, which is a square in this case. Now, if the base is a square, it means the slanting surfaces are identical. So you simply extract one of the slanting surfaces, find its area, and then it is the same area for the other 3 slanting surfaces. So you multiply it by 4. And then you get the total surface area by adding the area of the base to the total area of the slanting surfaces. And that gives you the total area of the figure. That was number 17A, and we shall be going to number 17B and C in the next video. Otherwise, this is Vision Plus, and thank you for being here. Number 17B, calculate VO of the height of the pyramid. If we go back to the given figure, they want us to find the height VO, that is the vertical distance, and VO is from V vertically downwards, as I've drawn there. Now, to solve this, there are many approaches, and I'm going to pick the simplest one. Let me clear every writing on this drawing. So from here, we are looking for the height VO, this height here. So for us to find that height, what I'm going to do is, I'm going to extract a triangle. Okay, I am going to extract a triangle. Which triangle? A triangle VOC. Okay, and then back to V. That is what I am going to extract. Alright, that means the distance VC is given as 7 centimeters, but the distance OC is not given. It is not given. This distance OC is not given. But if you look at OC, it is half of AC, because AC runs from point A up to point C, but half of it forms the OC, and now the other half forms the AO. So I'm going to extract that triangle that you have seen, and then we'll focus on the dimensions. So our triangle will look like this. It is now going to be a right angle triangle, because VO is vertical, and then we have C there. So this was our O center, this is where V was, and then this is where we had C. The distance VC was 7 centimeters, but the distance OC, we do not know this distance OC. let me go back. We don't know OC, but OC is half of AC. How can we get the distance AC such that we can get its half and then we use it as OC? What we can do is to extract. There is another right angle triangle here, that is A to C and then to B. That is a right angled triangle. Okay, why? Because the base is a square. Simply because the base is a square. So each of the angles of the square is 90 degrees. So on extracting that base triangle, it will look like this. Let me explain it from that instead of drawing another one. If you look at here, and I'm going to make a calculation here basically when we are referring to. So remember, this is a triangle here that we are looking at. Now, remember, by Pythagoras theorem, these are the two shorter sides, AB and AC. And if we square and sum them, they give us AC. So without wasting our time, if we get this 4 squared plus this other 4 squared, they must give us AC squared, which is the longest length we are looking for, AC squared. Therefore, if I square 4, I get 16 plus 16, I get 32 equals to AC squared. Then I get AC. AC here becomes the root of 32, which is 5. Therefore, our AC becomes 5.66 centimeters. So the length AC from here up to C all the way is 5.66 centimeters. But remember, we are looking for OC, and OC is midway. O is midway of AC. Therefore, OC is half of AC. So here, from here, our OC becomes AC out of 2. It is the half. Therefore, this gives us 5.66 divided by 2. And then you press your calculator. I'm getting 2.83 centimeters. Okay. This is our length OC, right? This is our length OC. Then now we come back. We have found our OC to be 2.83. So this length now is 2.83 centimeters. Yes. So I'm coming here now for the last time. So we have this distance that we had not known here now as 2.83 centimeters. So we can now apply Pythagoras theorem. So from here, we shall then have, this is our height, okay, VO. This is what we are looking for. So let me call it X. And by Pythagoras theorem, which you are familiar with, if I square X, then plus I square 2.83, it should give me 7 squared. That is by Pythagoras theorem. So therefore, we shall have X squared plus 2.83 squared equals to 7 squared. And then we make X the subject of the formula. Therefore, our X squared here becomes 7 squared minus 2.83 squared. And then you press the calculator. So if I press the calculator here, I'm getting 40. This is still X squared. I'm getting 40.99111. And then for me to find X now, I then take the square root, right? Therefore, my X here becomes the square root of 40.9. I'm getting here 6.40 centimeters. That is to 2 decimal places that I chose before. So the distance x is 6.40 centimeters, and therefore our height VO is 6.40 centimeters. So that is the height VO of the pyramid that we were given. Yeah, so that is the solution to part B, and we shall be going to the last part C of this paper. Thank you. The last part of number 17, part C. Using the formula V equals to 1 out of 3 times the height times the base area, calculate the volume of the pyramid. So the volume V is given by the formula 1 out of 3 times height times the base area. Okay, and if you remember from your revision, we said volume of a pyramid is the base area times the perpendicular height. So we just need to go back to the previous parts that we have done, and we get the height and the base. And the base area, our height was here 6.40, that is our height. So we say our height 6.40 centimeters, and then the base area, we say area of the base. Remember the base was a square, and the base area that we got was 16, right? This is the base area because the base forms a square, 4 times 4. So on going back here, our base area is 16 centimeters squared, and then this is our height. So we now say therefore our volume becomes 1 out of 3 times height, that is 6.40, times the base area 16, and this here gives us, on the calculator press it, I'm getting 34.13 cubic centimeters. Remember this volume, and 6.40 is in centimeters, 16 here is in centimeters squared. So if we say centimeter times centimeter square, this gives us centimeter cube. So the volume of this pyramid is 34.13. Let me confirm if I pressed it well. Yes, so this is the volume of the pyramid. Otherwise, we have come to the end of this paper. This was the giant mock examination board mathematics paper of 2024. I have solved it using all the possible ways that I can, from number 1 up to the end. If you have been here following, then we appreciate it. For each of the topics that were set in this paper, we have a list of videos for each of them. If you want to expand your knowledge and understanding on those areas, please do not hesitate to check out the playlist that we have created. Otherwise, thank you.